Right, Neil, you froze on me for a minute, so it scared me. So welcome to the T3 Alliance monthly trainings, 3 hours, 9 to noon each month. Our first one, we're going to kick off with Neldorio Perez in Puerto Rico and E.T. Lacey in West Virginia. And they put together some really cool stuff you guys are going to learn about advanced 3D printing and how do you make your Frankenscope, a telescope out of a 3D printer. So just want to welcome Neldorio and E.T. Online supporting is Corey Simpson, one of our trainers and support people over in Boise, Idaho. And then John Larson is also a T3 trainer and he's just participating today. So if you have any technical questions, he might be able to do that on the chat. And then last but not least is Jacob Au, our young star, who is such a bright young man who's figured out the Discord channel, the way we communicate during the training, and then also especially afterwards to help you keep connected and share your projects and cool things. So I'm going to go ahead and turn it over to Neldorio and then let you introduce Jacob when you're ready.
Yeah, perfect. Hello, everyone. As Roxy said, I'm from Puerto Rico. I've been working with Upperbound T3 since 2019, and it's been a wonderful experience. Um, and then we have ET also from West Virginia. ET, you can say something about yourself.
Yes, my name is Eugene, or ET. Everybody knows me by. I've been working with T3 Alliance for about 3 years, a little bit over 3 years now. I'm one of the first groups that actually started working with it. I'm based in Huntington, West Virginia, at Marshall, and it's pretty chilly outside today. I hope everyone else has better weather.
Thank you, ET. So, Jacob, if you can please, so we have Zoom. This is Zoom. We can talk about Zoom. If you want to have a speaker view so you can see the presentation and you can see our faces at the same time, at least speaking, you can feel free to speak in the chat and do reactions. If you have any question, you can raise your hand or just interrupt in any moment through the test, or you can talk. It should be okay. We can take our time. So, Jacob, can you please talk a little bit about Discord and where they can get the help?
Sure. So for those of you who aren't on Discord yet, we're going to be for every third Thursday event, we're going to be using the T3 Alliance community server. And I'm going to send the our website webpage instructions in the chat right now. So if you go to t3alliance.org/discord-instructions, you'll be able to just, it'll walk you through joining the T3 Alliance community server. And then under once you get verified and I'll get you in the system, you'll have access to many different channels. And one of these channels are going to be 3D printing. And this is where you can use Discord, and through this event, you can post the pictures that you've taken, or your update pictures, or you can ask questions there and so on. So Discord is going to be supporting this event. Use Discord as a support. Of course, you can still ask questions through Zoom, but we want you to stay connected in Discord so that after the event, you guys can stay connected and see updates on T3 Alliance. So again, if you haven't used or aren't on Discord yet, please go to this website that I sent in the link below, and follow the instructions, create an account, get access to Discord, and then join the T3 Alliance community server, so that you'll be able to stay connected with everyone after this event, and even during the event, still communicate, and add pictures and stuff. So yeah, we want these conversations to stay here after the event, so that Zoom kind of just the chat kind of disappears after this event. So we want to immortalize it. So yeah, back to you, Neil.
So thank you, Jake. Appreciate it. So this training, we're gonna speak about advanced Raspberry, not Raspberry Pi 3D printing, but the same way is basically a conjunction and a union of different things that we have learned so far. We already know what a Raspberry Pi is. We know what 3D printing is, and now we're gonna try to do advanced projects with it by uniting these both technologies into one. The materials that we're gonna need, I'm gonna change this, sorry, to presentation so everyone can see better. The materials that we're gonna need are the 3D printer, a spool of filament, PLA is okay, and then our Qidi software so we can slice. We're gonna be working today with ET's community engagement project, but I will be speaking about the telescope and explaining the process on where did I start and how did I finish, things to fix in the future. Feel free to add to it and stop me at any moment. A quick review for those who don't remember or need a refresh on the steps to print something. Once you start your printer, you want to load your filament, you want to level your bed, you want to slice whatever object is that you're going to print, and then print away. Always pay attention to what you're printing. Sometimes it doesn't come correctly, and you want to pay attention to it so it doesn't damage any part or component in the printer. So 3D printer applications, we're going to speak about these 3D printer applications using the telescope project as an example. The original idea is called PyCon telescope. It was developed by Mark Regley. He's in the UK. So he did a project on a PyCon telescope, and it was pretty amazing. And it's a 3D printed Raspberry Pi project, but only some parts are 3D printed, like a spider. You'll learn about that is later. Some components are and some are not. It was originally designed for like a contest and a festival in Sheffield University. And it was to prove what we're trying to prove, that the new technology is coming out, which is cheap, is very powerful, like the Raspberry Pi, 3D printing, all this stuff, and what students can do. Eventually, it turned into a crowdfunded project, so it became an open source project that anyone can edit and download to the likings. If you want the license, it's in the T3 C3 folders, and you can take that and share it wherever you want. So we're gonna start talking about, in my ways, or what I understood, is a telescope. There's a couple of them. This is an example of a Newtonian reflector telescope, where we have an aperture on the front of the telescope, which is right here, and that is pointing to the sky. At the bottom of the telescope, then we have a concave mirror or another mirror, which reflects whatever light it receives from the sky in this case. Then that image is pushed forward to a secondary mirror, and that secondary mirror will push the image through an eye or through a lens, which is the one that we see. The difference from this telescope and the one that we're going to be learning about today is that we replaced that secondary mirror and replaced it with a camera. So that way we use a camera to take pictures or to view what we want to view. So the PyCon telescope replaces the secondary mirror with a camera, and we can use a Raspberry Pi to automate whatever we need to automate. Now the materials, the original materials were bolts and nuts, pulleys. We have a tripod insert. This was printed. We got bolts, nylon nuts. So various things that you can find almost everywhere, except in Puerto Rico, apparently. Yes, it was really frustrating at the beginning, and you're gonna learn why. We don't use 5-inch diameter PVC tubes, not even electrical tubes. So it was really hard to find through Home Depot, to anywhere. Amazon had some, but they were very expensive. And I said, instead of following the exact same design, let's try and print everything. So that's where you become a whole new project of, I'm gonna print everything, and everything's gonna be 3D printed except the mirror itself. Yes, fun time. So we replaced most of the objects except the printer, except the actual mirror, sorry, and the 3 bolts that are holding it, because I need it to be secured. The mirror is really, really sensitive. One scratch, one fall, it can break pretty fast. So problems I encountered with slow delivery times. The UK mirror, when I bought it, it took almost 3 months to get to my house. And it was a little bit of a problem. It got delivered to me, and then to Mexico, and then back. It was weird because of COVID. Most of the screws and stuff are very hard to find, especially the pulley and some of the stuff that are there I don't have here. So for now, we're going to talk about the mirror assembly. The mirror assembly is the object that holds the mirror in place. Now, I use the original files, STL files, included in the project, in the open source project, because it was exactly what we needed. It's just a place where to put the actual telescope, the actual mirror. So what we need is a mirror mount, a mirror assembly. This goes on top of this, like this. So the springs have to be there. They help support stability on the mirror and vibrations. So they take a little bit of those vibrations out. I omitted them, and you're gonna see where that problem shows. I didn't know they were completely necessary at the moment. So when I finished the project, I'm like, yes, that's what I need, those springs there. Then we have to be very careful that the screws are not as long and that the actual glass is not touching anything metal, because supposedly we can break. All of this, we can talk to John later to confirm. I had never experienced a mirror before, so I was extra careful with it. This is how it looks at the end when it's completely assembled. This is a mirror assembly. This is where the image of the moon and stars and the skies bounce to the camera. As you can see, I don't have there the springs, and it caused a couple of problems down the line. Any questions so far? Good. Okay, perfect. We got Dominic. Now, the camera assembly. This was by far the most frustrating and fun project I ever worked, specifically in the camera. So because some of these parts were so hard to find, I had to start digging into engineering and looking for blueprints and all that stuff, and I'll speak about that now. So the spider is the same as the original file. The spider is this. I didn't change it because I thought that it was built with the specific design to let the most amount of light into the actual telescope. So I didn't want to change it, and it worked. The same thing goes for the camera. Now, the assembly allows the colors. This allows the telescope to take a picture, zoom in and zoom out. It's not really zooming, it's more like focusing what you're looking at. There's two options for the camera. You can use the version 2 camera, which comes with that white piece that you see right there, which is this one. And that allows you to unscrew the lens of the camera, because we don't need the lens here. We only want the sensor. And if you have another revision, which is the first revision, the one that comes with the pies, we have to be really careful because those do not unscrew easily, and then you can break them. So if you use a normal camera, then you're gonna know that you're gonna use it just for this, and then you may never again put something on top of it because it might damage the lens. So if you're a revision 2, you can basically use a camera in the telescope and anywhere else. If you get a revision 1, then you lose that camera, and it can only be specifically for the telescope or whatever other project that you don't need a lens on. So let's start with this. This is the first thing, and it was breaking my head. I spent almost 10 to 12 hours working with this. I didn't read, and we needed a T2.5 timing belt, like a transmission belt, timing belt. And it's a 10 centimeter piece. Yes, I can buy it. The thing is that I have to glue it to the actual camera mount. And I have read comments and people that have built this, that it comes off. So what I did is I decided not to buy it, not to waste some money, and then try to imprint the actual timing belt into the camera mount. So eventually what we did is that we started looking information. I looked at the information about how big it is, how small it is, and I did a lot of them. You'll see a picture later. You're only gonna see a couple, but I did so much of them, like 15, just making sure that I get it right. Because at the beginning I did it, and then I did the pulley after, and it all became a mess. So basically I looked for the measurements, I looked to how everything was set up. It is a 2.5 millimeter gap in between, and then a 2.5 thread, and then that continues on all the way through the end of the camera. And this is where the pulley can grab and then make the zooming and the focusing possible. So when this was ready, I was so happy. You can see the difference in the picture. This is how it's supposed to look. And then you were supposed to glue on top of that a piece of that 10 centimeter T 2.5 millimeter timing belt. So what I did is I took that out, and now I have it built into the camera mount. These holes right here are where the camera goes. So the camera goes on the other side, and it has those two sticks, those two bars. So that way all the circuitry is protected and inside the casing, and it doesn't damage anything. And then it goes basically attached to these holes right here. And you're gonna see later how do I attach those. And then the second nightmare was the pulley. So the pulley, I didn't find it anywhere here. I went to Radio Shack, we only have one. I went to Home Depot, And we do have big ones, but not small ones. And no electrical shop had them. I think you had to order them. So I went to Amazon, but then I ordered it, and it basically said it was gonna arrive in 2 months. I couldn't wait that long, so I decided let's do the same thing I did with the timing belt, and let's build it ourselves. So I looked for the blueprints, and I went online, and I went to Thingiverse, and I looked at samples, and I started building and editing. And by the way, everything was done in Tinkercad, which is not a super advanced um, designing software, but it works. As you can see, I went from smaller ones to bigger ones. At the end, I ended up with this one. This goes into the spider, and it allows it to stay in place and rotate. I did the first, this has holes in it because I was thinking of putting a screw through it, but it was not working. It was, as you can see here, it ripped, it broke. What you see black is where there was more filament, and I wanted to like clean it because it was not really straight. Um, and that was a design flaw. So basically, after multiple attempts again of making this gear, it was perfectly exact. If you see here, you can see it is basically the exact as those right here. So that's where the pulley attaches to it, and then it allows it to focus. And then the pulley assembly, everything came together here. These are the pins for the camera. So the camera fits here perfectly, and then I can put this through the holes that you saw on the camera mount, and it keeps the camera in place. I'm gonna move this so you can see everything. Sorry. This is basically the rotator. The original uses um, uh, a screw, sorry, and it uses some nuts and bolts to keep it in place. So what I did is I did a washer, and the washer goes with the pulley, and then the rotator goes through it, and it all sticks together, and it keeps in place by not having anywhere to go. And then the camera, you can slide it in and out. You're gonna see an example here. So as you can see, that's the washer, that's the rotator. I put it through the holes. The little knob that the pulley had goes into a little hole that is already here, and that allows me to do this. Now, the camera goes here with the pins that the ones that you saw in the last picture that I printed, and basically keeps the camera in place. Then with this, the camera assembly was finally finished, and I was happy to go forward with the next part. Any questions so far? No? Yes? Okay. See. Then came the biggest time-consuming part of the telescope. So the telescope tube, as we talked before, it was a 5-inch diameter PVC pipe. But the PVC pipe says a 5-inch diameter. We still lose some amount of, someone wrote, okay. So we lose an amount of spacing inside due to the thickness of it, etc. All these parts were made to fit that PVC pipe, specifically that 5-inch one. I don't have that, so I have to design this from the beginning. So I replaced that with a 3D printed tube. And due to the size of my printer, I had to print it in pieces. It couldn't be fully length printed 100 millimeters, etc. So it's 600 millimeters plus 10 millimeters, which is basically the same amount that the focal length of the mirror. So if the mirror itself has a focal length of 600, then you want to print a tube that is 600 millimeters plus 10 millimeters more. And that 1 millimeter allows for better focusing and other things. So have I read. It took 80 hours or more because I broke a couple of them trying to have the design correctly. At the beginning, I did everything by the number, and I forgot that I had to give and take. I'll explain where. And the tube is supposed to be black color. You see mine is blue. Again, it was a really long project. So at the end of it, I finished it a couple of days ago completely, no time to paint. But then paint also, as John said, might create glares. He suggested something else that I'm gonna talk about later. And then if you're gonna do this in the high end, I have here black paint, don't do it. You can use flocking material. That's what John that has a little bit of experience talked to me yesterday. That way the light is absorbed and it's not pushed around in the tube, causing glares. Okay, I'm gonna show you the design. If I can move, there we go. This is the original tube. And then this is how I made my tube. Due to the size of the printer again, I had to do it in pieces. And because of that, I needed to make pieces that attach to one another. I created like 6 of these before sticking with a final one. And even that one was wrong at some point. The first time I did this, the lip was the same thickness as the space that I have here. So when trying to unite them, they were so close together that I broke it in half. I still have pieces. For example, these pieces right here, hopefully you can see broke. Where I was trying to get that to fit perfectly. So that's where the give and take comes. And I make this just a inch bigger, not even 1 millimeter bigger. Then that gave me another problem where the space was too big and it didn't really attach. It just fed in perfectly, but then it failed. And I don't want it to fail. I want it to stay completely as a tube. So I resulted, or basically bought some Gorilla Glue and started gluing all of them together, and it worked, and it has stayed together till this moment. But it's still a little bit on the safe. It's not on the safe side. I think it can still break. So I'll talk about what can I do maybe in the future to make this better. So basically, I printed 6 of these, and that's exactly 100 each. So that's 600 millimeters. So I was missing that other 10. So for the other 10, and for another problem that I created this ring. So the problem was that I needed this to have this kind of wider end at both sides, because that's where the mirror goes and the camera goes. And when I put all this together, in the 6th tooth, I had this at the end. So the camera didn't fit, the mirror didn't fit. So it was a little bit of, what can I do? So I decided to do this ring where you can put it on top and then you can flip the last one of the pieces and then put it in. And that way, both of the ends will have the wider end. And then you can put the camera and you can put the mirror on. So that's how I solved that. Plus, what I did is I did it big enough to add that 1 centimeter to the tube, and it kind of worked perfectly. Like, I didn't know doing what I was doing. I kind of walked into this, and that solved the problem perfectly. Eventually, this is how the tube looks. It's kind of heavy. It's not as weightless as the PVT pipe. This is a lot heavier. It has a lot of filament inside. And then by printing this, we created more problems, but we can talk about that later. Now comes the tripod part, and this is where I gave the name Franken scope, because I didn't have a tripod. I have a camera tripod, which is really different from the telescope tripod. And what I ended up doing is I designed something to hold the telescope in place, and I wanted to glue it, and it didn't work perfectly. Now, for everyone that wants to do this project, and you're interested, is that when handling this, you have to find the center mass, because you want the telescope to be balanced for it to be moved perfectly and not have problems along the way. So you have to find the center mass by placing the mirror in and the whole camera assembly in, so you have the maximum weight of what the tube has, and then finding that middle point by balancing it. And once you find that middle point, you can Sharpie it, and then you can place that the tripod mount on top of that. So I did that with something that I designed. And then before I explain furthermore, I want to explain that I did not drill any holes in this because I didn't want any holes, any nuts inside that might fall and break the mirror. So the tube is completely clean in the inside. I wanted to do everything in the safest way possible. So instead of actually drilling in it, I glue it or try to glue it. So before doing anything, remember that that mirror has to be as furthest away from hard tools like drilling. So you want to remove the mirror and spider assemblies before actually doing the holes. Why? One, the camera doesn't have a lens, so all you have is a sensor. And the tiniest speck of dust is gonna damage the picture, or the tiniest piece of something that scratches is gonna ruin the camera forever. And then the mirror, the same thing. You don't want to have anything in it that falls. So imagine yourself drilling through the PLA that's getting hot and it's getting melted and it's getting broken, and it's gonna fall in the mirror and it's gonna damage it. So I needed to make a something that holded my telescope and I could attach it to my tripod, but it has to be able to hold the weight. I used my own design because the one that was on the project was not working for what I wanted to do it. I had to find the center of weight by balancing the telescope. So I came up with this. And this is where everything started to go, yeah, it's not working. Um, as you can see here, that's like a lot of glue and epoxy, and it didn't stick to the bottom part. Why? Because of filament. Filament is super, once it gets glued, it stays super slippery. It's not as easy to glue as other stuff. So at the end, I was able to attach whatever I printed to the actual tripod, but then I had to hold it in place. And I used the most amazing product in the world, the zip ties. Zip ties are pretty cool. So I used 3 of them and I made it super tight and it stays there and it worked. The only problem was that because it's not really attached to the mount, any slight movement will make the telescope image just go crazy. And then at the end, we have the Raspberry Pi. Excuse me. The Raspberry Pi can be mounted on the telescope on the top or on the bottom. There's already an assembly for it, but it was a problem. It was an old kind of version of it. We have a Pi 4, for example, I have a Pi 4 and a Pi 3. And the old telescope, the original one, used a second edition. Okay. So it had a second edition Pi. So what I did is instead of making an actual case for the Pi and then a holder for the Pi, I created a pocket. So a little pocket where I can put my telescope in. I was able to move freely in that pocket to do whatever adjustments I needed to. The command that I used and that was given to take the picture is a raster. Raster takes an image in the JPEG format, and it shows you a live view of what the camera is seeing. So that's pretty neat when you want to take a picture. You want to see what you're taking a picture before actually taking a picture. So you can set that by using -T, and then the amount of milliseconds you want to wait. So 1,000 milliseconds, 1 second, 2,000 is 2 seconds, and so on and so forth. And if you want to give a name to the image so you can save it, you use -O, and then the name of that image plus the extension. Because it's a JPEG, then you use .jpeg or whatever extensions that you want, and it will be saved. Now, this will be saved under home. Like if you go to the folders, you go to Pi, to home, and it will be saved there. It won't be saved to pictures, just because that's where the actual file is being saved. And this is all with the command line terminal. There's no user interface or anything. That's a project for the future that you might have. This is the design that I took from, so I took this from Thingiverse, and I edited, I took out the top, I added this too, in order to use a zip tie again and have it well placed. The problem, because I did it like this, is because my ribbon cable for my camera was not long enough. By not being long enough, I couldn't put it on top, or else I wouldn't be able to focus. So I had to put it on the bottom, and that's what you see. You'll see in the picture soon. So that way I attached it and I have the pocket there to put the Pi, and then I had enough slack of that ribbon to actually move forward or backwards, and I was able to actually focus on whatever object was, which the moon in this case. The final assembly is straightforward. Is putting the mirror assembly and the camera assembly all together, and then place your telescope on your tripod. Now, you have to make sure that the mirror fits snugly because it can fall. Mine fell, I just catched it. So I used black electrical tape right at the edge while with the mirror in. So that way it creates kind of a bond and it helps it grip so it stays there. And that's pretty cool. That worked perfectly. For further designs in the future, maybe make it a little bit bigger or a little bit tighter so that way it doesn't fall. Maybe even a screw cap might work in the next project. And then this is a finished prototype. This is Frankenscope, which is the one that I have in my bag. If you can see my picture, I have it right there. It has a little cloth on top because I don't want dust getting inside on the camera lens or on the mirror. As you can see the zip ties that are holding the actual telescope, and then the other zip tie that is holding the pocket right there, so I can put my Pi inside. and I was able to finish this, and this was the most amazing thing ever. This is how it looks from the front. This is the camera mount. You can see here some black tape. I did this because there's no stopper, so I didn't want it to go past that point. So what I did is I put some tape in it, so when it gets to the top, to that end, it'll stop and won't let me actually go forward. And then that's how the mirror looks in the back. Because it's closed, the further away you get, the bigger the image gets. So last night I spent about 2 hours trying to find the moon, which is right there. It didn't move, but I was trying to find it. Interesting story is that it's not that easy. Specifically because I didn't put the springs in it, and because there's no way to actually mean to know exactly at what point I had to. So after a couple of hours, maybe 1 hour and a half of looking in the sky, I was able to get the moon there. It was really blurry. It was more like a flash of light. And then I used the camera rotation device, and I was able to focus the moon. Now, it is a little bit blurry. I'll explain why in a second. This is one of the pictures that I took. This is last night here in Puerto Rico. The moon was like half full. You can see here. Then you can see that sometimes it got blurry. Actually, they're all kind of blurry. And I'll explain that in a second. Possible fixes for the future. So maybe have a cap to protect the mirror inside and the camera so it doesn't actually get some dust. The tubes, I would like to have a longer lip and a longer hole on the other side, so I'm able to actually have more support in it and doesn't come out as easily. I would like to revisit the pulley design because although it works, it's kind of loose. It's not really that tight as with the metal one. The metal one would have been tighter because it has nuts and everything, but because this doesn't have those components that the original project had, it's a little bit loose. So it does focus, but if you have to go a little bit further, so when it retreats back, either the ribbon cable pulls it back or the weight of the camera pushes it down. So I had to actually hold the focus knob to take the picture, and then at a moment it was okay, but then the wind blew and the movement of the telescope made the camera move again. So it was pretty difficult. So that's something that I have to look in the future, trying to make that better or tighter. So in future reference, if you're making this with the original parts, make sure that you have enough room and it's tight enough so that there is resistance for you to move, but there's also resistance for it not to move by itself. And then I would like to make a user interface. We already know how to use Node-RED. I think students will have a blast to actually have this on their screens and be able to move and then take a picture and not have to do it while the raster command is running and the time is running out. So if you have a live view of it, you can take pictures of it without having to have that time constraints. A longer ribbon for the camera because I use the one that came with the camera, which is short, maybe a 30mm one or something that's longer. The black interior is a plus. There's some blurriness because of also the amount of light that was coming in didn't allow me to actually focus correctly. Maybe a better tripod mount. I think I can solve this if I can mathematically know the exact point where this is going to be perfectly balanced. Maybe I can actually print the tube and the mount all together in one. So it will be like tube/mount, and that way it will be part all of it together, and then I don't have to go forward and get myself some glue or anything or other means of attaching it together. That way the tube stays clean. And then a stronger filament. I say a stronger filament because although PLA is pretty good for prototyping and for building and it's pretty sturdy, it's also like a stick. So it's hard, but if you apply a certain amount of pressure, it's going to break. And that's what happened multiple times when I was trying to put stuff together. A lot of things break. And because it's not as hard as ABS or as engineering kind of grade of filament, then stuff got damaged just by simple stuff. And then experience. So it was frustrating sometimes, but this is just like maybe 5% of all the things that I have thrown away or have saved in the box. so much stuff that I printed. But again, I put the word experience because this is how I learned the process of it didn't work, and you keep working up to the end. Now, I can probably do this again in a shorter amount of time and better, more sturdy, or the better version of it. Another thing that I would like to add to this is we have a Raspberry Pi, we got motors. We might be able to actually make a tripod that moves by itself with some motors, and that way the zooming might be better than with my hand, because it will be done in super small amounts, and that way the picture can be clear, and then we don't have to touch the microscope for everything. Everything can be automatic. So this is where I stop for now. This is a perfect place for questions and for a break. But first questions, thoughts, John, anyone?
That's awesome. I love it. I'm glad. I like the amount of innovation that you did where you were faced with a challenge and you needed to overcome it. The fact that you made a rack and pinion setup to focus is great, because those belts aren't necessarily easily available. I know they're in a lot of 3D printers, but sometimes trying to get replacements for them is very difficult. And the fact that you had to glue that in the original design, I like the printed design better. I think that will be a bit better for you and going forward, because that reduces the complexity of the focusing mechanism.
I appreciate it.
When you talk about moving the telescope, we use a term time to settle, right? Because every time you touch it, you're putting vibration in the whole system. And so you can't just move it and take a picture. You got to move it, let it settle, and then take your picture, which is not easy for something like the moon.
Moves.
And the Earth, the Earth is rotating, right? The moon actually moves at a different rate than the Earth. So you're working with a couple different variables in that system. It's great. The balance point, I think that they originally had the dovetail piece, right? That one piece that you had. Those are pretty much in use for everybody on every telescope, right? It's kind of one of those unspoken standards. And the ability to move it in there helps you with that balance point. I know that there's what they call a saddle, which is the receiving end of the dovetail. I've printed one, but I haven't used it yet, because I was doing some mount design about a year ago. So there might be some amount of cross-pollination of ideas on how to overcome that, I think.
Solve it with some research and see what works better. Hopefully that thing of printing that, because it's only 6 tubes, the weight of the mirror was specifically at that one tube. And if I can, because it's the same telescope, if I can make the design the same but better, or maybe with less problems, if I can attach that together, it maybe it helps be sturdier, but I don't know. It's just a thought about it. But I just
think
don't like it precise.
for the mirror cell, if there's room, you may be able to go in from the outside of the cylinder in with a couple of screws to hold it in. I mean, a minimum of 3. 4, you might be overkill. But if your final tube piece where the mirror goes, if you print it with the holes, and I mean we're increasing the complexity, right? But
try not to increase that.
Yeah.
So the question is, you have experience with telescopes, right? And the mirror. I'm like super freaked out with the mirror. I don't want to break it. So I don't want to have anything inside the tube itself. Does having nuts inside that telescope, like if I make a hole through the tube and put some nuts in it, will that affect the picture?
No.
Will I see that in the camera? It won't? Okay.
No. So look at how big the spider is on the front of it.
Yeah. Okay.
That you're still going to get light through. The only time that's really going to be any problem, and you'll actually see this, if a picture is out of focus, you will see the spider.
Yeah.
Right? Because it's in the path. But if you've ever seen, okay, when people are taking pictures of the sun, there's a special cap that they put on the front of the telescope, right? There's solar filters that do that, but they also occlude, they block off like 90% of the front of the telescope, and they have a small hole because they only need to let in a little bit of light. So the spider by itself isn't really going to impact much in what you're viewing.
So says Neil, this is amazing. You're just thinking about using the option of hot glue gun, hotter and more flexible. True. In what part? So
Maybe
so
for
again,
the mirror,
yeah,
but
for
the one thing about working on telescopes, and I've drilled through a metal tube before, so this is my experience. I didn't want to spend the time to take the mirror out. One, because it was 10 inches in diameter and I didn't want to mess up my alignments. But I always put the tube the farthest away. So for instance, if you're going to work on the front of the telescope, you angle that down. So like you don't drop a tool inside the tube and then it bounces off your mirror.
So what I did is I just left the mirror out. I was so scared.
Yeah, exactly. So a lot of people will remove the whole mirror assembly because they'll do an inspection like, okay, do I need to clean it? And you're using like distilled water and things like that to do the cleaning. So never use regular water.
So one of the things that I was thinking of, I saw that mirrors come, I can have a 4.5 mirror and have it be 600, 800, 1,000, whatever focal length it has. It doesn't have to do with the diameter, it's just how it's made. Now, is it possible for me to make, for example, I got this with a 4.5, 600 millimeters focal length. Is it possible to have a 4.5, the same as this with an 800 one, and just have like another part of this that I can attach to the same telescope in order to make it as long as it needs to be, and I don't have to build another telescope with another mirror. I just have to change those parts. So I have one telescope with different tube lengths that I can attach or detach, and then the same thing with the mirrors that I can attach or detach. And that way I don't have to build 6 tubes or have 6 cameras. I can use the same thing, but with the same mirror. How is that?
The trick is that the mirror is a parabola, right? So it's going to be concave, and so it's going to have a set focal point.
Yep.
As you increase your focal length, that's going to change, right? So the PICON telescope is optimized for the focal length where the camera is placed, right? Because it's not like it's a regular eyepiece telescope.
Mm-hmm.
So that focus changes in that range for you. It's just that set range. If you increase the length, if I remember correctly, the mirror side, it becomes a little flatter, right? I mean, it's hard to see. I mean, it depends upon those factors. Some mirrors are pretty much flat, but then like in the design earlier of the Newtonian, it looked like it was bending it towards the secondary mirror. So very small things. It's like the Hubble Space Telescope, right? When they launched it and they went, oops, we have a mistake on the mirror. And that mistake was the width of a human hair. So they had to make new instruments to correct, like they put glasses on it. Is essentially what they did.
Oh, okay, cool. So any other questions, suggestions from anyone, thoughts? John? Oh, hey, John, how are you doing?
Hey, Neil, that is amazing. The technicality that you put into it and just the patience that you put into making that is truly phenomenal. I don't know too much about telescopes or even photography, but I can look at your problems that you solved and just be amazed at it. And just using common, around the house pieces. I was thinking that, I'm just in amaze at what you've done here. And I'm wondering, were you able to tie this back into some project that you had going toward your advanced degree, or, can you use this in your classroom anyway?
I can use it for upper bound, like for Denise, but for my actual studies, no, I'm doing mathematics. I might be able to use it in a way, maybe my creative project at the end, because my master's doesn't require an exam, it requires like a small thesis or project. So if I'm able to use that for image recognition of the moon and stuff like that, then it should be perfect. But then I'll need to make it, again, a little bit better than what it is right now. Just fix those small um, irregularities that will make this even better. So fixing that might help me in the masters, and it might not. But again, it was a fun project. I already have one line up, which is a microscope, same concept. So heads up, it's gonna be another one.
Yeah, a microscope actually might be a lot of fun. You're not reaching out so far, but you know, John and I were just having a little sidebar conversation about we'd be, and probably everybody on this viewing this right now would, I think, be excited to help you produce this into an article, even if it was a web-based article about all that you've learned and what you experienced, and you know, for anybody who wanted to replicate this, and possibly even put together some, you know, some ideas for future, you know, expansions of it. But if you'd be interested in that, let's have a sidebar conversation and maybe get everybody involved and get you a credit for an article.
Oh, perfect. Thanks. Appreciate it. The picture was amazing. My daughters and my wife were, I was skeptical at the moment because I was not able to get anything. But when I finally saw this and on the screen, it was an amazing screen. My daughters were happy. My wife was happy. So yeah, I took a picture in my phone to compare, and I only had like a light, a bulb of light, and then this thing. So I'm even more excited things that maybe I can see Saturn next time around or something even better. So I appreciate it.
That's amazing. What do you think of that, Corey?
I'm loving it. I'm thinking like, oh man, what can we do to this? You know, how can we get this? And I'm super excited about this. Question I had for you, Neil, is you talked about your tube that you had to build because you didn't have access to the 5-inch PVC tubes. If you had a 5-inch PVC tube, how do you get it to be black on the inside? Do you paint it in there, or how do you squirt the paint in there to get it black? And then how do you make sure that it's not going to reflect, you know, light and stuff in there at the wrong angles?
I was watching videos in YouTube, and there's a lot of scientific guys. There's one guy that buys paint, like specific paint. There's paints that cost real expensive, but they absorb like 99.9% of light. And as long as it's matte, I don't think it's gonna be a big problem. Like for something like this, if I want to make it better, then I might want to invest in a paint like Black 2.0, which absorbs 90% of light, and then you won't have that problem. But if we have that, then just spray paint it or just paint it with a brush, because after it dries, like this type of paints, they will dry and you won't see nothing. There was a video that I saw of a paint, I think it's called Mobe or something like that. The guy painted a whole room and he was not able to see his face in the room, even with the light on, like a big LED light, like nothing, just completely black, just like space. So that might be something in the future that I'm looking to. Or maybe I can start by buying black filament and printing it in black, and that might be a start. Maybe not. So yeah, that's something I was thinking about, but I've not looked at prices of the paint or whatever. But then I talked to John yesterday about it actually, and he said that there is a flocking, and I know what flocking is because I know you can do it to the cars and stuff like that. How effective is that? Because I really don't know.
Some people use it to just modify their existing scopes that have already been painted, because even, you know, the manufactured scopes, there's just a light coating of black, right? But the flocking itself usually helps with that. The other advantage too is, well, how should I put that? No, there's no other advantage. It's pretty much just to get the light down, right? On some scopes, people have even put black construction paper at certain parts just to get rid of the glare.
Okay.
And it's not a permanent install. Sometimes they just set it in there and then they take it out.
Yeah,
just to see.
I'm learning a lot. It's like you showed me the foam thing. I have those around the house. My daughters like to use them so much.
Yeah, I've used hobby foam several times just to create a shroud, because on a telescope that has a lens on the front, when it gets cold, you know, when the dew point and all that, the moisture collects on the lens, and then you can't view anymore. But if you put a tube on the front of it, it's what they call a dew shield, and it just keeps the temperature inside of there enough that the moisture won't form on the lens. So I've cut out several pieces of foam that are long enough, then just put Velcro on it, and I just attach it to the telescope.
So now that you spoke about the sun, do you think it's possible for me to use this with a filter and get a picture of the sun?
If you have a filter, yes.
Filter, yeah, I tried.
It's tricky. The thing you're going to worry about is the sensor. But that's just a technological issue, right? That can be fixed. Your eyes cannot, right? Because you're going to try to line up a telescope.
Yeah.
So don't look at the sun. What you do is the sun casts a shadow. And so you have the sun to the back of you, and you're looking at the telescope, and then you turn it so that it looks like a round tube. So it's mostly in that area, right? There's a finder, there's a solar finder on Thingiverse that I've printed that works really well. It has a little dot, and you center the dot on the spot, and then you're pretty much in it. I used it in the eclipse a couple years ago.
Oh, that's perfect. And then so that's the sun. So I try to take a picture of the moon during the day, because in Puerto Rico, I think everywhere, but yesterday it was right there, the same moon, half of it, but it was during the day. And I thought if I can take a picture of that, it would look cool too, but it was impossible. And I think it was due to the amount of light that was coming in. So for that, I would probably need a filter too. It was
Yes.
all blue. Yeah. Okay.
With that size, you could probably cut out some old solar glasses for the eclipse, because that's the filter material, right? And it's small enough to cover that sensor. I've printed covers for binoculars and telescopes where I cut out the filter and put it in, but those are going to be a lot larger aperture than, say, that camera lens. So they say when you're doing a solar filter, you try to filter the most, because if you think about it, you're focusing light to a point in the telescope, right? You're also focusing the sun to a point. And we all know what happens to ants under a magnifying lens.
Burn, yeah.
So, yes. So we'd have to do a way where we can design a cap that goes on the front, and then we just have a section of that cap where there's a hole where that filter material goes, which could help you. I mean, you're still going to get a lot of light, right? But you can just reduce that down to reduce the amount of energy, or as we say, electromagnetic radiation.
That's pretty cool. Then you talk about the purple on the picture is radiological what?
That is usually chromatic aberration. So each light that we see, so like you got red, green, and blue, okay? They're different wavelengths. So they focus at different spots. Typically, a reflectress telescope does not have that, because it has to do with when you're having lenses and glass, and the cameras can do this too, but they use special glass to get rid of it. But in a reflector telescope, it doesn't happen as much, because you're just reflecting. You're not refracting the light. Hence the name of a reflector telescope versus a refracting telescope. So Newtonian, Isaac Newton.
Any other questions?
I have another question for you, Neil.
Yeah.
Have you used your telescope to look at, like as if you were to look out across the ocean, you know, to see ships and stuff that are way out there? You know, and how well are you able to see that instead of looking at the sun, of course, you know, just looking at at it to look for distance and things off in, off in the horizon?
I have not. So I finished the telescope. Today's what, Thursday? Yeah, today. No. So I finished it yesterday completely. I did try to take pictures yesterday around noon. But again, all I saw was blue. I think I had to point at something super, super far away. I wanted to try and get here in Pargueras, where I live in Lajas, but there's like a blimp that's floating in the air and it's attached to a string. And that's like a weather station radar kind of thing. And I was trying to focus that, but it was not possible. Now, I don't know if because of the focal length, I need to point at something that's really, really far away in order to actually see it, or I can focus something close and take a picture of that. But that I have to try, and that's where I want to see if I can make a Node-RED program in Python where I can have buttons and I can have gears moving the telescope searching and until I find something, and then maybe focus better with a mechanized gear, and that might be even better to take even clearer pictures or other stuff. Another thing that I'm interested is in constellations and stars. Am I able to take pictures of stars with this? I have no idea. I am?
Yes.
Okay.
Yes.
I need to know how to find them, and so that's another part of the experience that. So I had so much fun yesterday, so now I have to start learning about how do I find the constellations, how do I point the telescope to them, and not spend 2 hours looking for something in the middle of nowhere, which is black and dark, and hopefully take more pictures. I'm posting this everywhere. That's how happy I am. I send it on Facebook. I send it to all my friends. And I'm like, dude, after 200 plus hours of this, worth it every second. It was an amazing experience. Hopefully the telescope, the microscope that I want to do next, gets the same thing. I've seen that it's open source too and has a lot of things to do. So it should be pretty cool.
So you mentioned that when you move the telescope, it has, it bounces around a little bit, and I can't remember the term. I think, John, you said that there was a time to settle. The what?
Mhm.
Time to settle, yeah.
Yeah, time to settle. How long is that time to settle for your telescope? I mean, because you want to move it, you're trying to make minute adjustments to find the moon or find, whatever. How long does that take just to find something?
So at the beginning, I was doing 30,000 milliseconds, so that's about 30 seconds. And I would move the telescope, and counting, it was about 10 to 15 seconds if I move the telescope abruptly. So if I move the whole thing, and then it'll start moving, and I have to wait for it to stop. Specifically more because it's plastic and it tends to be more flexible, and I don't have the springs. The springs help with that vibration. I didn't know that, so that's something that I have to add now. But if I moved it like super minute, once I had the moon there, and I like tied that thing up so it doesn't move, I was using the legs themselves just to push them super tiny with my hand. And then 5 seconds, 6 seconds later, it will stop moving, but not completely. As you can see, I think the clearer picture is this one, and it still looks a little bit blurry, and that has to do with the vibration. As you can see here, the moon was here, and then it was here. You can see that space right there, and then at the same time, that knob, the pulley system that I had to revisit was sometimes when I moved the telescope, it moved the camera, so it was really difficult to actually get it to a specific place. I was even tempted getting a clamp and just clamping the thing there, but I didn't want to break it because I had to show it up today. So, but now that the class is done and we're doing this, I can keep playing with it. If I break it, I can go at it again. And I have to say, this printer, small, but at one point I printed for 3 days straight, no stop, no off button, and it went perfectly. The only time was when I scratched the surface of the bed because I moved it to take something out and I forgot the important step of leveling the bed. And it happens to all of us, and just peeled a little bit of the skin out to put it back in there. It was again a fun experience. It was tedious, but it was fun. It was not that tedious.
Has anyone ever had any success 3D printing springs before?
3D printing what?
3D printing springs?
Springs. I saw that, but then because I have PLA and PLA is not good for springs, I didn't do them. Because PLA, although it's sturdy again, it will break under pressure, under too much pressure. and I didn't want it to break and then the mirror move or fall or anything. Again, a lot of it took a lot of time, but it was me being what you call it, super careful, like just trying not to damage anything that will compromise one the class, of course. I want to give you training, or the telescope with the materials now to buy again, and I didn't want that to happen. Um, I went to the hardware store, and they do have springs, but they're big springs, and I had to see if I could cut them. And yeah, go ahead, Don.
I have an idea for that.
So,
Most lawnmowers, the throttle is a spring. You might be able to get 3 of them and then just cut them to the size that you want, because they're usually pretty small,
okay.
right? And those usually stretch out and they have to be replaced a lot. So that's probably easier to get than trying to get something from the hardware store. Or just say, hey, I need a throttle spring for a lawnmower, right? They're usually going to have a little bit of a spring and then a long part of it. You can probably just use the wire clippers and trim it.
Yeah, that was really interesting that when I found this online, I started looking, I'm like, I'm gonna make a list, I'm gonna go buy everything. How hard it was, especially John has come here to Puerto Rico, he's seen San Germán. We are like a rural kind of area. The big areas on the south and the north and maybe up the west, but on our area, all we have is like house building materials. Stuff like this small, it's kind of hard to find. And I didn't know it was hard to find until I started looking. And some places were just asking for too much. Like one of those pulleys, like again, there was a store here that sells stuff for robots and sometimes have stuff in all radio shop. They bought everything I was reselling. It was like $20 out. It was like 5 on Amazon. So why buy something more expensive? I just said, let's just take this challenge to another level and just print everything. Because right now, the only things here that are not made of filament is the screws and the mirror. Everything else is just made of pure plastic. And that's what I like about it, is just made of pure filament. And that's how far you can take a design, as long as you put time into it, you'll get there. So it was pretty good, pretty cool thing. Is there anyone else, Ingrid, or anyone else that has questions?
I like to make the tube and modify it to amplify my phone to take a picture of the moon. Just insert my phone in it. Take the lens to amplify.
Leota with Row. Sorry if I butchered that. It says sourcing supplies can be done in the U.S. and sent to Puerto Rico. Yes. I thought of talking to John, to Adam. I know they're always at the disposition to help me. Roxy, they said if you need anything, just let us know. I know they'll always help. Again, it was a decision of, do I want to get all the stuff and then just put everything together, or do I want to take this and just show up and show this eventually for students? Brian Regani want to do it for his students over at Alaska Upper Bound. I already talked to him about meeting and having his students do it. But the idea is for students to know that it is possible to use this and do something bigger, and to open their minds into more possibilities. The same thing with the telescope. I just showed yesterday a camera to ET. You remember the old cameras, the one that had the little sheet of plastic inside. I don't know how it's called. And then you click and you have to and do it again multiple times. Take it somewhere for them to get developed. A guy made a whole 3D printed camera that uses no electrical components, one of those rolls, and it takes pictures. And ET saw it was perfectly amazing. We got students that, although part upper bound here in Puerto Rico, that not as good in math or science stuff, but they're great artists. If you have a camera made of 3D printed parts, it takes kind of vintage cameras because it goes black and white. That might be a project that student specifically is interested in, and that comes with Stream, the new trend of Stream and all that stuff. So what I'm doing now is just researching in the internet all the multiple projects by integrating, Raspberry Pis and everything together. And that might be also a way of integrating all that students have learned with their Raspberry Pi courses and the 3D printed course and the flying drones course, and they can all implement all that into one amazing project, like what we did in summer, which was a Grow Power, the Grow Tower, and the drones and all that stuff. So as soon as they start integrating everything together, then projects like this come out. Imagine a student building this in Alaska, and maybe winter is is almost over, but next year you get the aurora borealis. They can take pictures with that, with this, I think. So that would be even a better concept of, hey, you built this yourself. It didn't cost that much. Only the mirror is like $60 maybe. The rest is just PLA. And then with that, you can take pictures of stuff over there. And then over there is probably better because you have no light. Like here in Puerto Rico, we got a light bulb in every corner. So so that light contamination helps, and you don't have that over there. So hopefully this telescope reaches up and down programs, and then they can implement it. It would be cool to see what, although I have my stuff, and I'll be glad to share everything. It'll be cool to see how students react to maybe developing their own ways of fixing those problems that I encounter. Um, they might have an idea that is a lot better than mine, and then they can put that forward also for their credits and stuff like that. So hopefully we get out there and it becomes a cool project with you too. So for now, we want to take a break so ET can, then he's part to take a 15-minute break. I want to drink some water, go to the bathroom. Oh, more questions.
So you said 15-minute break. We'll be back at, what time is it? Well, in different places.
It's 3 o'clock for me. It'll be 3:15, so it should be like 10 or 10 in Alaska. So just 15 minutes should be okay. I think they can do it. Yeah.
25 after. All right.
Yeah, sorry, I'm gonna get some water. It's kind of hot and dry today, so. Smart.
Hey, while we're waiting, I have something I want to show you guys. Let me do a new share.
Let me. Yep.
Oh, yes.
You guys seen this?
I've got one.
Oh, you do? This is the Raspberry Pi 4, and it's got all the connections here in the back. So all it is just a keyboard.
So that's a new Pi? Like a whole
Yeah.
Pi?
Yeah, the whole Pi is in here. And you can see that there's the card, there's where you hook up your SD or HDMI slots, your power, USB right here, and then your network cable.
I want one of those. I want one of those.
You can also get this little thing called this extension. You put it in here, and then it has all of your.
Yeah, I need one of those.
I need one of those. Yep. How is that called?
Oh, this thing's called the Quick Fat Extension for the Raspberry Pi 400.
So the whole keyboard is called Pi 400?
Yeah.
I remember Chester talking about that and trying to do a T3 extension for the keyboard so they can do all the inputs and outputs.
Uh-huh.
That's
It's
cool.
pretty.
Cool.
pretty cool. It comes with some little feet that you can stick to the bottom of it, so it's, you know, sits upright and you can press down on it.
So you just plug it into your monitor or your TV? How do you use it?
Yeah, well, I just got it.
Oh, you just got it?
I'm excited. I was like, oh, it came. So I just wanted to share it with you, show you guys.
That's cool because you can take it anywhere. It's small. Like me being a programmer, that's like super awesome. Just take the keyboard. Bye.
Yeah. Yep.
Do you know what those quick mounts are? The two connectors on either side?
I don't. Like I said, I just barely got this, so I haven't really, you know, been able to play with it.
I think it actually fits inside of one of those Raspberry Pi boxes. I think Chester said one of the versions of it, or like in the newer boxes, it fits right in the inside the tray, so you can use that monitor.
Well, it looks like it's a mount. That's what it says here, a quick mount.
I bet you they have their own little component thing for plugging in modules. It probably goes on top of the I2C bus, expands it.
Let's take a look here. That's quick. P-hat.
We gotta go over there.
This picture that you can see,
Yep.
this was taken last night, but by one of our club members. So this is the whole thing is Orion, and here's the Orion's belt, and then there's the Orion Nebula right there in the middle.
Oh my God.
You want to share that?
Oh yeah. Let's see. There we go.
So cool. Can I do that with mine? Oh my God, that's beautiful.
He's using a wide field camera to do that. This is a technique called stacking. So he took, I think he said 16 pictures at like 30 seconds each. He almost didn't make it into the location where he took the pictures because of the snowdrift. He almost got stuck. I almost thought about going down to help him, but it's like an hour drive from here. But you can see a little bit of cloud on the belt, and it's just amazing what you can get. Now, this is a wide field shot, so this isn't like the telescope. So this is probably a 35 or a 50 millimeter camera lens.
Okay.
But this is Beetlejuice up here in the corner, the orange red.
That's pretty. I need to learn how to do that with my camera.
If you've got a wide lens, it's fairly, as long as there is a formula to do it, right? So like if you've got, say, a 35 millimeter lens, it's called the 500 rule. So you take 500 divided by the focal length of your lens. That gives you the number of seconds that you can take the picture without getting star trails as it streaks.
Oh, okay.
Yeah. So that's why he did short shots, short pictures, and then stacked them together, because he could get more light that way. But there's a lot more to the technique that you have to do, because he had to take what's called dark shots. So he puts the lens cap on and puts his coat over it and takes a bunch of pictures. You have to do like all the same pictures at the same time, because the temperature affects the sensor. Like how warm is the sensor? Digital sensors, you'll have noise, right? So you stack it to try to get rid of the noise. That's how that works.
So I'm gonna
By stacking it, you mean the pictures are, it's like,
yeah, the pictures. So
yeah,
there's some software that you load all the photos in, and then it like puts them all together, and does a comparison to say, okay, that's noise, that's not a real pixel, right? So the dark frames, as they call them, all you're going to see is your bad pixels on the sensor. So they use that to subtract them out of your images.
Cool.
I didn't realize you weren't looking at me.
So I'm gonna change. Can I share again?
Mhm.
Yes.
Okay. I'm gonna show the next projects that I have in mind before going to ET. This is a microscope. It's called an open flex microscope. It has motors, 3 lenses. It's pretty straightforward. People use it, and it's even lab grade. So there's ways to make it useful for like labs. So that's one of them. This is the camera that I mentioned earlier that uses the film all styles. He lifts hands back. So you lift that up, this little stick, and then you click it and it goes down and it makes something that has a hole in it, put some light through it, a specific moment, and it takes pictures. These are the pictures that he took with that 3D printed camera. So it's kind of pretty cool. And then this is the one of the, I don't know the name. Yeah, her. And she posted this. This is another type of telescope, also made from 3D printed parts. It looks pretty cool. So
I saw that a few years ago. The guy who had worked on it had built one.
Is this open source too?
I believe so. And it uses some of the same parts that you would find on a 3D printer, like the extruded aluminum parts.
Okay.
But that base is really complicated.
Yeah, this.
Mm-hmm.
I'll look into it, but I like this one. I like my Frankenscope. So this is we saw earlier where the specific. This is the first and original camera mount, and this is where I engraved the threads. Each of them, I did the first one here, and then I copied that one over multiple times until I got to the base. That's why this one is bigger, so it doesn't go closer from that. And then here I cut it off, and basically this is the same image just with the thread there. And I think it is better because now it's cheaper, and this is one is cheaper and I have to buy a belt, and then two is already there, so I don't have it doesn't require me more work from me or from the student that's going to be doing this or anything else. It's already there. I think that was pretty cool. So we're gonna change this, take this off, and then ET, whenever you're ready, let me know.
Hey Neil, sorry, one more question. I thought about when you print those little grooves for the gears.
Yeah.
You know, sometimes when you print stuff that are really small like that, it leaves little stringers, lack of a better word. Do you find that does the same thing when you print that, and does it make any difference?
So the first one that I did, it did that a lot, and they were smaller and closer, and they were so small that they actually snapped. The stringer thingies, that has to do with the temperature and the retraction speed of the filament. So when that moves from this point to another point, it leaves a trail of filament. That's what you're talking about? So that is due to the printer extruding something before actually moving, so it doesn't rip apart the one that is already cold on the print. And you can go to your settings and tell them to like go slower, or to actually at that specific moment to just extrude a little bit less when it's moving away, so you don't have the stringing. But if you do that, you can clean it with water, and then just you can get a knife. I had just a couple of them. I got a knife and it just like cleaning between and took them apart. At least for that one, the last one that I used, I didn't have that much of a problem with stringing, but I did with the other ones that I was designing at first. So again, I'll share all of this in the C3 folder. It will be under STLs and then telescope parts. I'll include everything that I used, my designs, but remember that they need tweaking because, well, I have zip ties on mine.
That sounds great.
Yeah, no problem. on this. Ready? Break. Here we go.
All right, so now we're going to talk about design thinking and community engagement. And then after that, I already uploaded a file to the chat box, the fork we're going to print off later. And then also there's a copy of it in the folder for T3, and it should be on Discord too for 3D printing. So you have it in several different places. I really like design thinking and community engagement aspect of it because for the last 10 years, I've actually been working for another program that the hallmark of it is doing STEM projects that actually have a requirement of having to do something positive in the community. So that's why I really like this aspect of it, because it really gets the students involved in trying to help their community. And one thing you notice is that when students are involved in a project that helps their community, they're more likely to persist in that project and are more likely to see it through its completion rather than just doing a simple task and getting a grade for it. If they have like an end goal or something they can see that's going to be a good result, they're more likely to stay in it. Just give you some idea with some of the projects I've done in the past with my other programmers. For instance, we have a creek in our area where a lot of students play in the water, and our students were wondering, like, if we know bacteria is prevalent in our area because they don't have the best sewage system, so sometimes the sewage may go directly into a creek or a river. So they wanted to see what's the bacterial content of it. So they partnered with one of our teachers in the local high school, and they actually went out and they tested the water for different things, for bacteria or for different bacterial strains in the water. They actually had to help create the agar plates to grow the bacteria, things like that. And one unique thing about our area, which is not a good thing in Huntington area, is that several years ago we were known as the unhealthiest city in America. So our students really grabbed onto that idea, and they like, what can they do to help the children in our area improve their health, and some of the adults. So actually some of our kids went to local elementary schools and junior highs, and they actually did these projects to help kids become more active. And then other students, for adults, they actually did a health fair where they brought in a bunch of different individuals, like teachers and community members. And I think we had about 65 or 70, but the only reason why we had so little is because we ran out of A1C kits because they're kind of expensive. But our students act as clinicians, where they actually went through and they filled out their forms, helped them fill out their forms. They took their blood pressure, took their weight, calculated their BMI, and then we had a nurse that volunteered to take the A1C because they had to deal with needles and blood. So I really like getting students involved in the community, and our students, like I said, they love and they gravitate to these kind of projects. So typically when you talk about design thinking for us, we're talking about first, we want to have our students empathize with the individual they're going to be working with. That's a critical step because it's going to get all the information you need so you can actually define that problem. And then our students are going to come up with different ideas of how to solve that problem. They're going to build their prototypes, and they can have another stage to it where students can actually fill out mini grants, which I'll talk about later on. They're actually going to test that prototype. And the testing part comes in, we have to come back and maybe make modifications, do a different prototype, maybe go back to the individual and see what you might have missed initially. As we go to the next slide, the first step is empathize with the individual. This one, I like this picture because it's showing the dog with the hood over his head, and then you have the cat in there. Because sometimes when people empathize with individuals, they try to look at it from a distance. They're like, oh, I understand. But this picture is showing that the cat is in there with him, understanding his plight of, being underneath that little hood. There's a nice picture out there where it shows someone who fell down in the pit, and there's somebody looking down in the pit trying to empathize with them. Then there's someone down in the pit with them trying to truly understand what was going on. So this step is truly important because it really helps you understand what the problem is. Obviously, don't judge in this one. And it's important, like when you do these kind of community engagement projects with design thinking, to maybe have the students in teams. Because, when you listen to someone, you may miss something, but when you have a team of individuals listening to someone, you can actually pick up more information. And when it gets to the other steps, you can have more ideas come in to actually try to fix the situation. The next slide is a cool thing that I pulled from one of our previous trainings. Try to help individuals learn how to be active listeners. Sometimes we like to jump in when someone's talking, or we try to fix that problem immediately without truly listening to them. But I like this because it actually gives you prompts to what you can actually say, because sometimes people don't find the right words to say to actually get the information they need. So you can say, for clarify, for instance, it says, say more about that. Can you give me an example? One project that I've been really wanting to do for a long time is partner with a nursing home. That pretty much came about because one of my friends, they were in a bad car accident and they lost mobility in their arms and their legs, but they were slowly getting filling back in their arms and their hands, but they're still having trouble being self-sufficient. And, a lot of becoming self-sufficient when you have injuries like that can help build confidence and help limit the amount of depression that you go through. So it can help with recovery. So one thing we wanted to do was actually build these devices that can hold silverware, so they don't have to have a tightest grip to hold the silverware. And I'll show you later on, but this is right here is just a little picture of what they could do with that. So when we go to what I want to do is take my students to the nursing home, and they're actually going to interview people once COVID is over, obviously. And they're going to go through this process of trying to actually figure out how they can help these individuals. I'm not going to give them the cheat sheet and show them that spoon, the handle for the spoon yet, but I want them to actually figure out, how to get to that point. And then also, there may be other issues where it may not be a spoon that the person needs. There may be something else to help them get through or help them get back to being self-sufficient. Perception, it depends on what type of project you have or what kind of questions you'll ask the person, but it may be a project where you want to say, how did that make you feel? Has this ever happened before? But one key thing is you want to always summarize and make sure you're on the same page with that individual. So far, what you seem to have said is what? So you want to make sure you reiterate what they actually told you. And then once they actually match up what they told you, what you're saying, you want to make sure you paraphrase it just to make sure you're on the same page. Because that's a very important part of it is getting exactly what you need, the information you need from the individual. One quick note over here, it said avoid dominance by a few members. Sometimes when you interview individuals, there's always that individual that sticks out, likes to talk the most. So you can try to gently defer to someone else to see what their take is on the problem to help you get more information to figure out the problem. And just try to switch off, may say, I'm gonna give everybody a couple minutes, or have the group interview individuals individually. That can really help you avoid getting people to talk over other ones. On the next slide, so once you gather all your information, you want to define that problem. This is why it's so important to have a lot of students in the group, or have at least several students in the group, because you want to bring in all the information that you learned, and then you want to define exactly what the problem is, what they need to solve. You want to have everybody come up and synthesize the idea of what they think and pretty much narrow it down to one specific problem. Like I said, that's a key step. That's why empathizing with them, getting as much information as possible is super important when you want to actually get to that problem, define the problem. The next step is going to be ideate. You want to come up with different ideas. So this can be tricky because sometimes you have students who make fun of other people's ideas. So typically, before I do this process with my students, I actually went over with them and had them practice on each other. Then I told them specific things. I'm like, don't talk down to other students. There are no bad ideas. It's just an idea. And one thing about it, as adults, we know that typically that final product is a combination of multiple ideas. So usually one person doesn't come up with the solution to the problem. It's usually a combination of different aspects of what people think. So make sure you emphasize that there's no bad ideas. Have everybody bring the information to the table, and try to do it as professional as possible. Like I said, we actually practiced this twice before we actually went out in the community. I let them practice between themselves, and then I had them practice with one of our summer advisors. And then we actually interviewed our greenhouse staff who had a problem within the greenhouse at Marshall. So the more they practice, the better they'll be at it. And I like it because students take on these leadership roles where they're professional. When they interview, I don't step in and say anything. They do it completely themselves. And I like creating that leadership aspect of it where they can really take control of the situation. The next step is going to be prototype. So you have all your ideas, and during that idea phase, you can actually draw out your prototype, and now you want to start to think about building that prototype. The picture that you see right here, this is from Hawaii. After the volcano, they had issues with air quality. So the students actually, they went out and interviewed people in the community, and they figured out what some of the issues they had, and the issue was air quality. So they wanted to build these, air quality sensors that actually can sense, I think it was sulfur. So people can know when it was safe to go back to their homes, or if the wind blew in, it was like unsafe to go there. So that's one of the cool projects you can do. But prototyping is just, it's just a prototype. Like you heard from Neil earlier, sometimes the prototype the first time doesn't work, so you got to go back and make adjustments. And typically when you prototype a 3D printing, you definitely want to use like a PLA filament, something that's a little bit cheaper. Later on, we'll go over some of the more expensive filaments, but PLA is something that you can definitely prototype with, and it's easy to replace. Then the last part is just testing your product. So you want to go back and test it. So for instance, if I made the silverware for the individual, I will actually want to go back and see how it works for them and have them make suggestions. If there is an issue with it, you can go back and modify it. I did a little cheat sheet with this one. So this right here was actually designed for a specific silverware from IKEA. So I just purchased that online because I needed some new silverware anyway. And I just took a couple forks and spoons away from it and I put them inside it. But one thing you know about 3D printing and design, you can actually adjust your models. So you can just go through, you can actually change the width of the insert for the spoon or the fork or the knife, whatever you need to do, and adjust it. Typically, no one's lucky enough to where they go through this process and they get it right the first time. There's always going to be some kind of adjustments. And that's what this diagram over here is telling you with the arrows going back and forth, is that once you test it, you may have to go back. It may not work perfectly. You have to go back and think of new ideas, or you may have to go back to the individual and empathize with them and get more information. You may miss what the problem was and have to define it again, build another prototype and test it again. So it's a whole process. And one thing I learned in doing these different projects is that measure twice and cut once. So you always want to have everything set before you do it, because when you're doing an 8-hour or 9-hour print, it's horrible when it doesn't work right. I know Neil may have their problem before, because most of his prints were about 6 or 7 hours. So yeah, so that's pretty much how you do design thinking and community engagement. If you guys ever have any questions, or I think these slides will definitely be available, you can come to me. I think we went over these in the first training too. So that's just a little overview of it. So next slide. Oh yeah, the mini grants. This is that process I mentioned before. If you go to the next page, it shows actually an example of the mini grant. So for what happens is, so we actually doing prototypes, and it's something that's expensive. So you want to build those sulfuric or air quality sensors they did in Hawaii. That's probably a more expensive project, because they may be in an area where they may not have power, because obviously the lava came through and it wiped out some of the power lines and so forth. So you actually have to buy a power source, either long-term battery, or you have to buy a solar panel, which I know some people actually buy solar panels to power some of their projects. So that's not cheap. So you want to make sure before you actually make a big purchase, especially if you're dealing with grant funds, that you have a good idea what these students want to do. You don't want to buy a bunch of things you don't need at the end of the day. So this allows them to actually go through that grant proposal process, and they get the use of like filling one out. And sometimes you deny it, you can decline it. So if you see the paper right here, the first one is like they list their names. They do a description of the project, just like you would do with a normal grant, except it's just a mini grant. They want to go exactly what's proposed and how you're going to use the money and resources. And I like the part where they sketch a diagram. This diagram, actually, they used this outside of a library that had the windows broken out because of a storm. So what the students did, they were building a project where they had a motion sensor security cameras outside, so they could monitor who's going in and out of these buildings with broken windows. So they actually drew a prototype of the library, and over here you can see the camera and the Raspberry Pi kit. And again, that's another project that's going to require a lot of money, because obviously if the area has been destroyed by a storm, you're going to have to buy some kind of power source for it, and have somebody monitor it too. A lot of these projects, you have to talk about who's going to come out and monitor it. You have to see if it's going to be in a place where there's no rain's going to hit it, things like that. So then they just do a description. They price out all their objects and what they're going to do. And then on the next page, they go, how would you projects are going to work on, I'm sorry, the next, on the other side of the screen, how they be evaluating it, how they're going to testing it and so forth. And then at the bottom of it, your director, they submit it to the director. They can either approve for funding or decline it for funding. If they decline it for funding, they usually tell them to go back and fix these certain things with the comments. So so that's a really cool thing. If you guys want copies of that too, just let us know. We can make those available to you. But mini grant proposal, I think, is a really cool idea. So some community engagement ideas that I've done that I'm planning on doing in the future. In the past, I think I showed off the early flood detection system that I did, where we actually where it actually sent an email if your basement was flooding or something like that. But this is actually the silverware holder project. Again, if you have your computer, your device up, you can go ahead and download that file, and we're going to print it right after I finish this little section. But like I said, again, the reason why I wanted to do this, because I had a friend who had a bad accident and they had trouble with their silverware. I have 2 different models that they can use. So this one right here, like I said, is built specifically for IKEA spoons and forks, like a specific brand. But like I said, you can actually go in and change the measurements through the 3D design software. Just put it in the Tinkercad or another program. And you go to the next slide, you can see how the silverware fits into it. The forks actually fits perfectly with it. And the spoon was actually pretty loose. So I would actually have to go and monitor it or go in and modify this one so it can actually fit tighter. You can probably see on my screen, there's like a rubber band that helps keep it tight. That's why they have that little groove on each end of it. So individual can go in. One thing about this is we're doing with silverware, you're probably going to have to wash this at some point. That's when we're going to go into what type of filament will be best for different types of projects. So that's one thing to keep an eye on. So the next slide, we have a different one. This right here is, I really like this one actually, because it can actually have a lot of different functions. So you can just put a fork in it, the silverware, and there's also a cup function. On my screen, again, you can see where you can actually have different attachments. So like individual can make a fist and grab a cup. They can just put their cup in there and use it to drink. There's actually another attachment where they can actually use an ink pen. So this one's very versatile. I really like this one. My hand is a little bit bigger than a normal hand, so it doesn't fit exactly. But also remember, there's different types of filaments. So I could probably use a flexible filament, and it can actually, be flexible, be more comfortable in the hand. Or I can go and just modify this one and make it bigger to where it can fit over top of hand. And that's one thing you may learn when you actually go to the nursing home. When you make that first prototype, it doesn't fit the individual's hand. You can go back and change the dimensions of it so it can't fit their hand. Next page or next slide, it just shows a picture of it. Like I said, it's pretty simple. And I posted these actually. These are in the T3 drive on Discord, or T3 on Google Drive, and then on Discord too. So you can have access to these files. But it just shows how the cup holder works and how you can put different attachments on there. There may even be more attachments. I just saw those 2 initially. The pen, the cup holder, and then the fork or spoon. The next page is something that I really want to do. A long time ago, I actually worked in a daycare for a couple years. So I like working with kids. And then my history students, they inspired me because I told you earlier, they went out and they work with kids in the community. So I thought about, they work with kids trying to grow plants and things like that, or healthy food. So I thought about what would be a good way to get kids, our kids, involved with younger kids to be mentors and help them do something that's fun. They can help them maybe do healthy eating too. So I printed off these planters. And they're like little cartoon characters. Cause I figure if you're working with younger kids, if you see something that's a cartoon character, it may actually help them be more engaged in the project and will like it more. Neil actually recommended the other day that we can probably put holes in it and make it a chia pet where it can grow out. If you want to do like some kind of fun thing where it can grow everywhere, which would be pretty cool. So these 2 guys can have some hair, just put some grass, or have a mustache coming out here, something cool. But what I plan on doing with this project is actually getting my high school students partnered with a daycare that I usually work for. Actually, it's in one of our lower income communities, and have them go out and they can show these kids how to plant and maybe plant some vegetables. And what we learn actually from our students projects again is that when kids actually plant their own vegetables, they're more likely to try them and eat them rather than just getting them from their parents or from the store themselves, which is weird. If they grow it, they like it better. But then another thing I thought about too, if I can print this off in white filament, they can just paint this actually and have the kids paint it, and then they can grow stuff in to get them more engaged in the project. So our students are taking on a leadership role. They're using the 3D printing technology, and they're getting out in the community and trying to help kids be more educated about how to grow plants, and just doing fun activities to get mentors. One thing about this, though, I have to say is that, again, depends on what type of filament you're using. This is PLA filament. PLA is somewhat water resistant, but it's not great at water resistance. I think the rating is medium. That means over time it's going to absorb water and break down a little bit. It's actually biodegradable. I read a story where you can actually put this in a compost heap and it'll break down over time, but it may take a couple years, I think, but it'll still break down. So a couple ways to get around that is, I have some slides later on, but you can actually coat it with something that's waterproof to make it last longer, or you can just use a different filament that's waterproof, that gets more water resistant. So this actually is one of the water resistant filaments you can use. PETG, glyco modified version of polyethylene terephthalate. I probably butchered that name, but it's just waterproof. It's the same plastic that they use in water bottles. But this, like I say, if I did this in the future, and I think this wasn't expensive. I thought it was. I think it was only around $20 or $25, and PLA is around that price range too, maybe a little bit cheaper. So I could actually buy this filament and do the planner project with, so it'll last a little bit longer. So that's one of the materials that you can use for a project if you need something that's waterproof. So just to give you an overview of some of the filaments and what it may be best to use for different projects. PLA, it's a great project. It's a great filament for just simple projects for prototyping. That whole telescope was built by PLA, so it's actually pretty durable. It's great for a lot of projects, but I say if you have something that involves water or something that may needs a little bit more stability or less heavy or less dense, you may want to go to a different type of filament. But the great thing about it is low cost, stiff and good strength, good dimensional accuracy, pretty good shelf life too. My PLA isn't probably stored the best, but I've never had any issues with it. And it's just a great filament to start off with. Some of the cons of it, that it doesn't have great heat resistance. So if you think about sometimes when you peel off your PLA from the platform and it's still warm, you can kind of smush in the edge of it because it's still kind of melty, and your platform usually doesn't get that hot. So if you could think about if you make a planner and put it outside in Arizona in direct sunlight, it may not hold up as long if it's on that concrete in direct sunlight. So, just think about things like that when you're trying to pick your filament. Next one is ABS. ABS is one I used previously. One thing you have to be careful with ABS is the temperature control. If you have the size to your 3D printer, you have them off of it, make sure you put the size back on your 3D printer and put the lid back on top of it, because it can dry very quickly and become brittle, and it can break up and it will turn into a mess. One time I got confident with my 3D printing, so I just started it and I left the room, came back, and it was a pretty bad mess. So it can actually warp and lift up from the plastic too, so it has to be temperature controlled. PLA, I have the size off of that. I have zero issues with it. ABS, I had a lot of cracking and stuff, and I don't use that one as much anymore because it actually gives off an odor. And I have my 3D printers in my office, and you have a small space with that odor. It actually was giving me a headache, and I didn't realize it for a while what was going on, but it was actually the ABS filament. So make sure you're using a well-ventilated area, and just make sure your door is open or have a fan blowing out so you can get the air circulating. But it does have a rough smell. Does anybody use ABS regularly? John, do you use it? No? Sometimes. Yeah, I haven't used it in probably a couple years now. Actually, I pretty much use PLA. The next slide. Someone say something.
Oh, I just say when I ran out, I didn't refill it.
Yeah, like I said, the PLA is just, to me, it's just a lot better. It's just a lot smoother. Prints are a lot easier.
I also think it has a little bit more shrinkage, doesn't it? So, yeah.
You don't control that temperature. It'll shrink up on the size of it and just bow up, and you just lost the whole print. Especially if you see it sticking initially, then you leave, and then it just starts going up. You got to redo the whole print again.
Yeah, I heard that when you design something that you're gonna specifically print with ABS, you want to give it a little bit more of size. So let's say I want to print something that's 2 millimeters, I might want to go to 3, because that shrinkage is not much, but it's just a little bit, and then you might get it to the exact point where you want it. So that's something to think ahead. Like if I wanted to do this with ABS, it would be even more of a nightmare than it was with PLA, because I need to account for that shrinkage.
Yeah, that's what we do. Like I said, I just avoid it now and just use the PLA. The next one is TPU. This is actually a cool filament. It's a flexible filament. I don't know if anybody had a lot of chance to use this one, but typically it is difficult to print initially. I did find that as one of the cons, but once I got like in that sweet spot, it works perfectly every time now. And this one would be cool for something that, say for instance, that silverware. You want something that's not as rigid, a little bit flexible, where it's more comfortable to hold. That'd be perfect for that. I printed out face masks at the first part of the pandemic, and it was in PLA, so it's kind of rough, but I thought about just printing it in TPU, where it'd be a little bit more comfortable without having to have something around it. So, but it's flexible, it's soft, long shelf life. This one doesn't have great water resistance either. It's about the same as PLA. So over time, it will absorb water. So be careful with that if you want to use something that may be exposed to a lot of water. But overall, it's pretty good. Has a lot of versatility when you have something that's flexible. What do you say, John?
E.T., did you use it on the Qidi printer, or do you have a different printer?
I use it on the Qidi printer. Yeah.
Huh. I had a lot of trouble getting it to
Stick.
extrude through it, and I was wondering if Neil maybe had some different experiences.
Yes, I know that Brian and I had a session because he couldn't print it. We have to go a little bit higher. So the problem with these filaments, when they make them, they don't all come with a specific range. It's not always going to be 220 degrees. It can be more, it can be less. So for him, he had it at a temperature which was in range. I think it was like 240 or something, but it was not printing. So we had to go a little bit higher. The way we did it is, I don't know if someone here has already gone to the first class that we did for 3D printing. We go in increments of 10 degrees, little by little, until we start seeing that string of filament coming out. But the other thing is that this pulls and pushes so the way the motor works is a little bit weird. So it might be difficult because of that too. I think this is one of the best options to print because it's pulling the filament and pushing it through and not actually pushing through, but it might cause problems. And if you're not paying attention to what you're printing and it goes the wrong way, you're just gonna have a sticky mess everywhere. And when I say everywhere, I know that Brian had a lot of time. He had to take all the components out and then heat them with when you load something and you preheat everything to load your filament. So he got everything hot and he has to wipe it out and scrape some stuff out because it was that sticky. So yes, it is a pain. I have a spool around here that Denise gave me to test, but I'm like adamant of not using it if I don't have to, because I don't want to have a mess and then have to clean up a lot of it. I might eventually have to print with it, and I want to, but at the same time, it's the only one I have, so I want to make sure that it's clean all times for different trainings and different things. So just increase the heat a little bit, and then make sure your bed is also heated so it sticks to it too. Yeah. I think Brian did rings. He did some finger rings for the kids. I think they were in 4th grade, so that way they get stretched. They're not as tight. So yeah, just little by little increase the heat, and just pray to God that everything goes all right.
Yeah, I actually had the gunking up with PLA before, where it was something clogged up and I didn't notice, and it was like literally an 8-hour print. I came back, it was completely covered it up like one massive blob, and I had to heat it up in order for it to scrape it off too. But with TPU again, like I said, it took me a while to get it going. Like it was always messed up, it wouldn't stick, and then one day it just finally started working, and it's been working perfectly, perfect with the TPU now. Actually, we just bought another 3D printer. I haven't set it up completely yet. It's the X Max from Qidi Print. So I'm going to set that one up, and you can actually use, I think it gets hotter than the normal Qidi printer, so you can actually print more filament types with it. So I'm excited to get that one going. It may actually work smoother with some of the filaments too.
Yeah, that's something that you have to pay attention to when you're printing. You want to read the manual, because you might buy some filament that's expensive and then you cannot use it at all because your printer is not going to be able to take care of it. And then what you can do is at the end damage the printer. I mean, if you put filament that's hard enough and the printer doesn't get hot enough, and you put it to the extruder and it gets stuck, how are you going to get it out? So, and then you have to dismantle the whole thing just to get that out. I had a friend of mine that has something like this. I think it's the before version of this, and he called me and he told me my printer's not working, and he tried to print engineer kind of material with it. I think it was PEI or something. It was just something that you need a lot of temperature, and it just got stuck in the motor. It didn't even get melted, maybe just the exterior of it. So you have to take the whole thing off and actually pry off and buy some other parts to get it working. So you want to look at your printer specifications to make sure how hot it gets and what type of filaments have been tested with it. And you can try to experiment as long as you have more parts and stuff to fix. So don't be afraid, but be careful. That's what I say.
Yeah, the great thing about these first 3 filaments I just covered, they're all reasonably priced. They're like $20 to $25, depending on what day it is on Amazon. You know how they adjust their prices to how many people viewed it that day. But they're all pretty like $20 to $25. I have, like I said, TPU is, like I said, it's pretty cool. It gives you a lot of versatility. This was actually in TPU. It does have a little stringy on the side, but it actually came out pretty well, and I really like it. But those are all reasonably priced. There is another filament out there. We actually looked at it earlier. It's called Peak Filament. $861 a spool was the price on Amazon that I saw. So that's actually for high-end engineering projects. So probably these professional companies who are prototyping maybe for NASA or some other manufacturing company will use that type. There is another filament out there. Maybe Neil knows the name of it. It's the kind that builds supports, but it dissolves away. I forgot the name of it just now.
I think it's PVA. It's made of alcohol and other stuff. It melts in water. If I'm not mistaken, it's PVA. I can make sure I'll get back to you when we finish the presentation. I don't want to stop it. But yeah.
Anybody who's printed anything before, typically you run into a part where you have to build supports. And the one thing about supports, they're great because it allows you to print your model, but sometimes it leaves something behind and doesn't get like a nice clean surface that you want to have. That would be the benefit of using a filament that actually dissolves in water. But again, if you use a filament that dissolves in water for your support, you may want to have a very high water resistant filament you're using in general. So that's what this kit over here is for. Like, so when you do build supports and you can't exactly get a clean print, you can use these to actually get rid of some of the extra filament that may be stuck to it. I actually bought one of these recently. The one I got was actually for carpentry, but it has all the tools that I needed. So I started building things that has gears and so forth. So a lot of the gears, I'm gonna put on my camera. I don't know if anyone can see that, but it's a lot of stringy mess for it to like spin around. So it won't screw on. So I got to go in. I have to clean all that off. This is actually part of one of my students want a camera holder, a phone holder for their just to hold their phone up so they can talk and do TikToks. I guess. So I have to go in and clean that off for them so they actually can screw on and work perfectly. But that's why one of these kits are very essential, especially when you start doing a lot more 3D printing projects. You need to get one. Actually, they have a Dremel right there. I have a Dremel at home, but I haven't had to use one yet, but actually can help get rid of some of the major stuff. Or if you need to drill a small hole to modify something, that's another reason you want to use the Dremel. But if you do that, though, you'll have to change your infield if you drill holes into it because it'll need to be solid surface in that area or on the model in general. What were you saying, Neil?
I got a comment on Dremels. So PLA, right? One of my telescope tubes that I did the first time was a little bit too big. It didn't feel in the wider end. So I did use a Dremel, which I have right here. And be careful, because if you want to do Dremel, it goes fast. And what it does, it melts the plastic and not cut it. I used a stone to see if it fixed, and then the stone was working better. It'll take a little bit. So you want something that's more abrasive than less, because the less abrasive, all you're doing is basically friction, and it gets hot and it gets melted, and I damaged the tube. So the tube spent 12 hours printing, and I damaged it in 10 seconds. So they are cool and very versatile, but then be careful that you don't apply too much pressure and that you don't take either too much or that you just burn it and then damage the whole thing. I just went through that.
Yeah, you gotta definitely be careful with a Dremel. Like I said, I haven't had to use one yet, but I use all the other things. Like I said, you have to, once you start doing some of these prints that have to be very precise, you'll definitely have to be doing some kind of modifying at some point. The next slide just shows, like I said, sometimes you have to sand down the surface to make it smooth, depending on what the part is. If you do print off, I know sometimes people print off drone parts, propellers and things, so it probably needs to be really smooth. But when it comes into these different finishes, this would be something, for instance, say for instance, you don't have something that's waterproof for filament. You may want to coat it with something to make sure it's waterproof and it lasts longer. I haven't had to use these that many. I don't think I've used any of these before. One time I just coated it with some, I think it was wood glue, maybe the same as this filler, but that actually worked out for me and waterproofed it for me, just some wood glue.
I have used the primer. So I had some white filament. It's no longer existent because we used it all. To paint, as you said earlier. So if you got a student that wants to paint something like a structure and art kind of way, and you have like red filament and it'll be impossible to paint, if you buy primer, specifically the one that's sandable, once you put it on top and you wait for it to dry, Now you have a white surface in which you can paint, and then paint will even adhere better to it. So that's a cool thing to have in your pocket if you want to paint stuff. Got some person from trash. Okay, that's see ABS. That's emit odor. Yes. So ABS emit odor is because it's made of petroleum, so it's not a biodegradable one, and because it's oil based, as in any other plastic, it's oil based. Once you burn it, it's gonna get fumes, and it might be dangerous to print on a closed environment. So windows open, a fan, or whatever you want, and just not be in the room while still paying attention. John can fix that. Yeah, John has a good setup with camera. He can be in Walmart and watch his printer. I have to do that too.
Yeah, I was lesson the hard way. ABS.
Yeah.
Yeah, I was literally printing it for probably a month, and then I just noticed I had a headache. I'm like, "What's going on?" I'm like, "Oh, I forgot about that part of ABS." Anybody have any questions about anything, this telescope or community design? If not, we're gonna I uploaded the file for the fork that actually, or the spoon holder that this type. That's the first file that's in there, and then the second file is this one that you can actually modify.
If you don't remember,
and add different attachments.
I'm gonna do it on my computer, so if anyone has trouble, before we can do that, I think Stephanie has some messages she wants to give. If she wants to do that now, she can. Are you there, Stephanie? Maybe not yet. Okay, so I'm gonna start downloading the files that ET uploaded to the chat. You can go to Discord. You can go here in the chat, and he hides them somewhere. You just download them to your computer. You'll go to your downloads folder. Yes? Oh, I thought someone was speaking. This is really old type of saving. So I'm saving into my downloads folder. So we can go into a downloads folder right here, and then you should have whatever file ET had. This is a hand support fork and spoon, and you should have a zip file. I got WinRAR, so it appears with books. For you, it might appear just as a folder with a zipper. What you want to do is extract it, and then you'll have the file itself, and then you'll have the item inside. And you can open that with your Qidi Tech software to slice it. It's not gonna open with that. You gave me a weird file. I'm gonna download it from the original file because you gave me something weird. I got two. FPP. It's not an STL file. I got this one. I'm gonna do this one because this one is opening.
I might have give you the condensed file because initially I couldn't upload it into Discord because it was too large. So I condensed it. I should put the regular one in there.
Please.
Regular size and Zoom.
So this is the Pac-Man Ghost Clan tool. It's pretty cool. Do you need to use support for this, ET?
Oh no, that one didn't take any support. I don't think. No, I didn't take any support. Even the eyes came out well. Yeah, I was surprised because I did. I use this other program where it just does. Click on auto support just in case it has anything anywhere and maybe suspected to fill in, but it was actually solid. Even the eyes, and that was in PLA.
So this is going to take approximately 6 hours.
Yeah, maybe. That was a longer print. Yeah,
maybe even more. 12. So yeah, this is going to take 12 hours. ET, can you please upload the STL file for
the fork? There is one for the first link I put in. The fork is STL. Can you see that one? Is it 223?
maybe. Let me go to the folder itself. You put it on Zoom?
Yeah, it's in the Zoom chat box.
Okay. Yeah, I saw it this morning. Thing story. Yeah, that's correct. Okay. So the first one, oh, there you go. Fork STL. Save. Just delete these. Right here, the open file, and fork. Just so you have an idea of how many I printed, all of these blue ones are all the telescope times that I had to redesign and sign again. And there's more here and more and more and more and more. So yeah, never give up. Just patience, lots of patience. Sometimes I will redesign something and do the exact same thing again for no reason. So I'll be like, okay, I need to take from this, but I don't do nothing, and then I'll print the same. It's pretty cool. So this is the fork. So question, how do you print it like this going up?
Yeah, I printed like that, and it came out good. I think that one might have had supports somewhere. Let me double check.
4 hours.
Are you using Qidi Print for this,
Yeah.
or are you designing it in another thing and then bringing it over?
Well, this one was already designed. I brought it over, but I can just if I need to, I just edit in Tinkercad. But yeah, this one was already designed, and
Okay.
I use Qidi Print. Sometimes I use Flash Print, which is the older one we used to use. It just depends.
So I'm inclined to see if we can split this print in two and then print them flat. It might be faster than 2 hours, just for the future. Might. I'm not saying it is. So one of the things that I noticed is, for example, if I print an object like the camera, it came original like this, like some weird thing, and it took 4 hours. By moving it to another position, is faster because it goes faster horizontally than it does up. So if you got a tall object, that increases the time because it goes down just by 2 millimeters every layer. Now, if you flip it one side, the longest side, you flip it horizontally, it's faster to go 30 meters per second than 2 millimeters per couple of minutes. So some objects might print faster while laying down in the horizontal way and have the shortest path or the shortest amount of material going up, and that will decrease the amount of time significantly. Now, it doesn't work with all, but it's just a heads up that something that I noticed while printing. But at the same time, sometimes changing the object horizontally will require supports, or it won't print correctly, etc. So um, here I was inclined to putting this one sideways because it's flat. It's completely flat, but then I noticed that this has some sticks here. So this will be kind of impossible to place down unless you take those off and then print them separate. But then that will be creating more problems for yourself. It might be faster, but then it's more parts. So you stick it like this. I think it should work. But it still takes 4 hours to actually print. So if you want to start the printing, just prepare and slice it and then put it on the printer. I want to talk about the designing softwares just a little bit because we are running out of time soon. So the softwares that I've used before is Tinkercad. I use Tinkercad for everything just because of how simple it is. I do have Mesh Mixer. I have not played with Mesh Mixer a lot. It is completely free and it's advanced in a way, but by being so advanced, it is super difficult to do. So something here that would take me 2 minutes, it might take me an hour there because I don't really understand it. And then Tinkercad, although it's simple, is pretty good. Now, Fusion 360 is another thing that is even more advanced. I did some research and it might be free from some institutions. So like for about a year. So if you're an institution that you got students and you want to use them, if you have an institution email and you go through the chain of command of the Fusion 360, you send your emails correctly, you might get a license for a year or even 2 years for free if it's not for commercial use. And for hobbyists, the same thing, but there's a process that you have to follow. The same with AutoCAD, which is for houses. Go ahead, John.
I was wondering if you've tried the Google Illustrator and then
I
convert it.
And I also use SketchUp. Google SketchUp is pretty cool too. You can build stuff just like in Tinkercad, but differently, because you can raise stuff, and it's like an architect kind of software, like for engineering and making houses and stuff like that. But if you want to make an object, you can draw on it, and then you can pull and do all the holes manually. It's more interactive than Tinkercad, a little bit more on the high side, but it's still easy to use as Tinkercad. I don't know how much, I know people like advanced stuff to do more stuff. I don't know how inclined I am into teaching students software that might get them even more confused about stuff.
Yeah, I was just trying to, I've been kind of stuck, and so any input from any of you would be helpful.
Yeah.
Of trying to find a middle ground software, but that has the same ability, that I can do things with the 3D printer, but also, since I've learned the application, apply it to the laser cutter, because it seems like I'm stuck in between all these, having a learning curve on all these softwares. So any input would be appreciated. So that's why I'm kind of thinking about this. I think on the laser cutter, they're recommending the Google is it Illustrator?
Illustrator, yeah.
Yeah.
And I use Adobe Illustrator. And in fact, I use that for the a T3 keychain that I made. And the nice thing is you can do stuff in, it's all in 2D. So it's one single layer. And then you save it as I think it's an STL file. Then you can import that into, what's that one that we were just using? The AutoCAD one, the simple version. And then you have to extrude it into a 3D. And you can lift it up and lift different portions of it up and say, okay, I want this to be in 3D. So that's an easy way of doing that. Yeah, Inkscape, John, is an open source version of Adobe Illustrator. But those
Adobe Illustrator, it was Adobe, but Illustrator, it's okay. It's not too hard to learn. You feel like it's
got a learning curve to it, but the nice thing about it is you can use, you can take some pretty complex designs, and especially with text, you can use whatever text font you want, as opposed to the CAD one. You're limited to just a handful of text fonts, and so with Illustrator you can do whatever you want and then just extrude it out into a 3D object.
Okay. And that seems like that one's not too terribly expensive if you're going to use it, monthly.
Yeah. I get the whole suite, so it's about $450, I think, a month or a year. Sorry, for the whole suite. So it includes Photoshop, Illustrator, InDesign, and the whole, even Premiere, Adobe Premiere, which does the video stuff. So you get the whole thing. That's the educational price, and yeah, it's not too bad.
I have no input in it. I have not taken yet I'm about to talk to Adam, and I think it's Dom, the ones that are doing the laser cutter classes, because although Denise is interested, so I might have to take the class and do the same thing I did with the printer and just get good at it. So after I take the class, I'll get back to you. Myself, I have no input.
ET, what are you using?
For designing or modifying, I just use Tinkercad most of the time. I was going to try to use the Fusion 360, but I ran into that the free trial, you have to be an educator issue. But Tinkercad has worked pretty much for everything I've needed so far. We just have to. It is a little bit cruder. It's a little bit hard to get everything specific, but the longer I've used it for a while now, so it's a lot easier for me to modify things with it.
I don't know if Blender works. There's a program called Blender, and it's used for sculpting and 3D design. But Blender is like, it's like if this is Tinkercad, Blender is the moon. It's hard to use. It's really, really difficult. You can even do mathematic functions in there. So it is pretty good software, but it's, at the same time, its learning curve is huge. So that's another option.
Yeah, the Blender interface can make you cry. It's just so complicated.
Same concept of Tinkercad, just there's so many things you can do in press, and then one thing might erase everything. It's just difficult.
Can I mention something about Tinkercad?
Yeah, go ahead.
Because of its open nature and free for use, there are a lot of YouTube videos how to get out of a pinch or do something like that. I have found that very useful when I'm trying to, how am I going to do a screw thread or whatever? And there's usually 1 or 2 or 3 or more videos on how to do that. Some of those complex functions, somebody's already done it and made a video. So
Yeah, like Googling things with 3D printing is like your best friend. You can pretty much find anything you need on Google. So many people have been doing it for a while, and it's just I go to it all the time. Like when I want to find something or model, um, go there, and you can just usually a lot of stuff is open source. Surprisingly, you'll find some places where you have to buy things, but a lot of cool stuff is open source, which is great for students because you don't have to worry about having to have them pay for anything.
Almost everything that's 3D printer related or Raspberry Pi related, all this stuff, almost 9900% of the time is open source because that's why it's in the market. Remember, this was government. This was secret. There was no one. Only the government was able to do these things. And when it came out to the public, and the public itself started building this stuff, it became public. As a public thing to do. The things that you have to pay is like if someone really did something pretty cool and designed a software that helps you do something, like Heroes Forge will help you do mini figurines for D&D and stuff like that. Well, then you have to pay for designs because they're using their stuff. But almost all the stuff is open source. I don't know why, but I love Tinkercad. It's maybe because of the simplicity of it. That's probably why I like it so much.
Yeah, I always, with any of my prints or anything like that, I always end up in Tinkercad. Even if I do something, outside of it, I bring it into Tinkercad, tweak it a little bit, and then that's the last one that goes in before I go into the Qidi print to do this slice or the slicing.
Okay.
Thanks, everyone. Thanks. It's really helpful.
I did upload a second file. It takes about an hour and 18 minutes on my printer to print. That's what time is giving me. So maybe shorter or longer on yours, but it's shorter than the other print. That's the print where you have when you can add the different modifications to it. This part right here.
I can always go here, and I like the Pac-Man ghost, so maybe I can make it super tiny.
Yeah, you can shrink it down. Yeah.
Just have like a little tiny toy. Let me see. So if you have never edited nothing inside Qidi Print, if you go to like scale, you can do uniform scaling, or you can take that off, and that will do crazy stuff. If you have uniform scaling, then you can say I want to print only 10% of this, like 10% of the size, and you'll go to like a tiny version of it, like a toy kind of thing. So now I have it small enough. So if I were to print this, it's not gonna be pretty. It's gonna take 6 minutes. So that's gonna be like super small.
Yeah.
Yeah, I'm gonna go like maybe 25 or something like that. That's cool.
Yeah, I printed the Pac-Man pretty big, and I printed this one pretty small, so it's less time. But I thought the one was too small, so I printed a little bigger one. But
that's
pretty
40
cool.
minutes. And I think there's more stuff you can do to this. Let's say you don't want to look in one way, you want to look at the other. You can mirror it, so now it'll change positions. So I made a mistake once printing an eye patch. I think I already talked to you about in another class. All I needed to do was mirror it here, and it will switch sides, and I was gonna be able to do it instead of actually redesigning the whole thing. So it would be cool if they had like Qidi software, and you can print from it and slice, and also actually program or design something. That would be something pretty cool. One software that does it all, but that's not the case right now.
And another cool place to get project ideas in general for Raspberry Pi and for 3D printing. I don't know if anyone else has attended a Raspberry Jam before.
Yes.
We have a bunch of Raspberry Pi enthusiasts come together. It's not just Raspberry Pi. I actually see a lot of 3D printed stuff there too. But that's another resource. They probably either went virtual to Raspberry Jams, or they're going to come back pretty soon. But what it is just literally a bunch of Raspberry Pi enthusiasts and other hobbyists, and they come in and show all these different projects. You can get a lot of great ideas. When we had a couple locally, they had the first one like 3 years ago. I took students to them 2 years in a row. They got to see a lot of cool projects, and they really like it. I was actually planning on trying to host one in Marshall, but things just fell through at the last minute. But I'm hoping to do that again in the future, try to host a Raspberry Jam where the students can actually show us some of their projects, 3D printing and Raspberry Pi. But it's pretty cool if anybody gets a chance in their area. They're all over the world, literally in every country, or not every country, but on every continent. But if you get a chance to attend one, try it out.
I just had if they do one here, they've done them. I think I went to the 41st, 41. They did one in Puerto Rico, and I went. If they do it again, this might be a good idea to have there.
Oh yeah, that would be awesome. There, they'll love that.
Next one I do, I want to see if I can actually engrave the T3 logo in the printer. It should be cool. Instead of having the sticker. Yeah, I have the sticker. I have a lot of them, so I just stick it there. Okay, take this out, and that should be it. So my printer is preparing to print. I would like, we have like 30 minutes. I would like to talk about, receive suggestions on future projects that you might want to see me integrating, like us integrating 3D printing with Raspberry Pi or other things. I already have a couple of ideas like the microscope, the camera, and all this stuff that I've seen on lookup, but sometimes your input does matter. So if you have any ideas of projects that we would like to see, I'll be glad to get them and see what can I do with them.
One of the things that we've been interested in is like a garden monitoring system. So I've been playing with Sam. We've been working on like moisture sensors, or it'd be fun to maybe have a camera that took a picture every day of a plant as it grows.
That would be really cool.
Or something that hold a solar panel that would trickle feed the the raspberry, anything like that, a little wind gauge, because you can get the sensors, you can pretty much buy all these sensors, but they're a little bit expensive. I wouldn't, not terribly, but just getting them, as Neil's figured out, it took forever for them to get here. And then between Alaska, Puerto Rico, and Hawaii, half the stuff never makes it here.
Is the BM280? Is that one does temperature, humidity?
Yeah, it does humidity, temperature, barometric pressure, but then because it's not protected, it needs a casing. So that's a good idea. Like all the sensors are there in the Pi. So if we can make or design something with a 3D print that can house all this stuff, and maybe you can stick it on a pole, and then that will serve as a monitoring system for pictures, as a movement. You can use the movement one for any animal that goes into the garden, and then you can see it, take a picture, humidity, wind, temperature, all this stuff, and then he can have inside vision of it. That would be pretty cool. But we have to house it.
Yeah, I started, this little arrow grows.
To plant stuff?
Yeah, it's got the lamp over it, and you can grow herbs and salads and things, but the little trays break. So I've been trying to print up some of these little caps that float, that go into it. It's not perfected yet.
It's getting there, and that's exactly the experience that I had. It didn't work the first time. I print a lot, like 2 spools worth of filament just disappeared mid printing stuff. That's why the spider part is white and the rest is blue, is because the white was over, so I had to switch to blue. And I have nothing else in white. The only thing that's white that worked was that spider. The rest is a whole spool of just complete messes of, but you'll get there. So I know you will. I think Stephanie wants to give some announcements, so I'm gonna give her a time to speak. Hi, Stephanie. You're muted. There you go.
Sorry. Yes. Sorry. I stepped away from my computer for a second. So do I have the ability to share my screen? Yeah.
Yeah, we can make you. Corey, can you give her co-host? Stopping my feet. There you go.
Perfect. Okay. So I really hope you guys enjoyed today. I was only able to pop in for the last hour or so because I actually have a new staff member joining today. And I know everyone knows that feeling. But so if you enjoyed today, please look to see what we have upcoming in the near future. So in February, for continuing our third Thursdays, we have mini grants and place-based learning. March, we have grow towers and hydroponics. So John, maybe that one's for you. You can keep going. April's a big month. We have student field trips using the T3 philosophy. Love it. And then in May, we have Mavic mini drones. Did I say that correctly?
Yes.
Okay. I just want to make sure. And then the list goes on, but I don't want to overwhelm you guys for our third Thursday list. And like I said, April's a big month. Also in April, to help prepare new staff for the summer or anything like that, we have another onboarding coming up. This one we have partnered with NVSU for you guys that know Jerome. That is his location in T3 site. So that'll be April 29th and 30th. So get the word out for anybody who still needs onboarding, new staff, graduate students that might need just to start from scratch or a refresher. We're really excited to be able to offer this before the upcoming summer for sure. So that's pretty much my announcement. More information is on the T3 website, and registration links are open for I want to say for the next few months for sure. So thank you guys.
Thank you, Stephanie.
Thank you.
So yes, I am a fast speaker. This is supposed to be till 3, but I have to learn to pace myself. So we got extra time for anything that you want, ideas.
Does anyone have any cool ideas they've done with their students already, or any other potential ideas you want to do with your students?
Yeah. Great topics for third Tuesdays. Oh, that's for Stephanie, the message. Oh no, that's it then. Well then, I appreciate.
I had a, sorry, I was just kind of thinking about one, thinking, should I ask it? So have you seen the mostly printed CNC machine? It's what they do is it's a CNC machine that you can make, but you use 3D printed parts to put it to build it. And the only thing you need to get is that you can buy it through a little kit. You can actually even, they give you the list of stuff that you can outsource and get it yourself if you want. But that's one of the things that I'm wanting to do, because I want to build my own skis. And so I want to get a CNC machine so that I can cut out the skis and stuff. And I think it'd be really cool if I could make this, that I could then start making skis for some of my students who, you know, are also underrepresented and underprivileged students, where they can then participate in a sport like skiing. So that's kind of a long-term idea that I've got going on, but I really want to make this the CNC machine.
Okay, I have it here. I'm making a list because I really want to see what projects we can keep expanding. With this one, I started this one and I just got hooked. So that's why I'm asking for more ideas. I want to see what else can we can, you know, we can achieve by exporting this printer. How big is that CNC machine? Is it like small? Is it big?
You can, you know, the nice thing about it is you can make it as big as you want. I just put the website up there on the chat. You can see, so you use piping, and that's what I like about it, is because, you know, for skis, you need a long, you know, like a good 6 to 7 feet long, but you don't only need just a couple feet wide. And to buy a CNC machine is thousands and thousands of dollars, especially something that big. But with this 3D one, so there's one version of it, and then if you go down to go up to home and go click on Lowrider CNC. That's the one that you can kind of build yourself, and you can make any size that you want. And with all the parts that you get, it's about $300 for all the kind of the hardware that you're used to put it together. And then of course the actual router itself is, I don't know, another $100. So for about $400 or $500, you can have a complete CNC machine. And that's what I'm really wanting to do, is this lowrider one.
That's pretty cool.
Yeah. So, you know, it's got belts and stuff. There's a bunch of YouTube videos on there. So people shows how they've built them and put them together. Yeah, in fact, if you go back to that front page, the main page, and scroll all the way down to the bottom, you can see some people who've done it and put it on. Yeah, there's the lowrider that there. Just use some rollers on. You can put it on the side of a table, and so you can store it. You know, put it away. You know, when you don't need it, take it apart. People have modified it so that you can automatically what do you call it? Zero it in, and they've used it with Arduinos as well as Raspberry Pis and other types of computers to utilize this thing. So I'm just super excited about this one. I think this will probably be a next project that I'll work on. But again, they give you all of the STL files to print off those parts to build this CNC machine. And you can also, I think you can also switch out, instead of using a router, you can use a laser and make a laser cutter out of all this, or even put a 3D printer. So it's kind of very versatile. You can, you know,
basically make a bigger printer. That should be cool
yeah,
too.
Yeah, exactly.
That's nice. I like it. I have that noted here. So CNC machine with the garden idea for John. Anything else you want to add? How about you, John? You have a lot of projects. I know you've done a lot of them. No? Okay, then.
Corey, when you did that project where you did the remote control sensors that went into the mines, did you want to do that project?
Say that again.
Did you do a project where you had like remote control vehicles drive into a mine or something to test air quality? Was that
No,
you? That
wasn't me.
Someone did something like that where they had like a remote control drone or something that went into a mine or shaft or cave that tested the air quality. It was pretty cool. But I guess like if you attach the Raspberry Pi and sensors to like a remote control car, you can, all the housing and the support can be 3D printed, you know.
Yeah.
I was thinking of making a drone. I don't know how versatile that would be, like a 3D printed drone. But then I don't know if the Raspberry Pi would be able to.
Yeah, you need to talk to Adam. I think he built his drone using a Raspberry Pi.
Okay. That means it's possible, so I can print the whole thing.
Yep.
I don't see. Oh, there you go.
We had some students do that with a Pi, and it was very intuitive. It was good. The only thing you have to buy the motors,
yeah,
and the flight controller and the props.
So basically, only the housing would be 3D printed. You know?
Yeah, but it makes it versatile because when it crashes, you can fix all the parts, and they do crash.
Yeah, I had one and I flew it once, and then the second time it didn't crash, but the wind took it away, and it got so far away that I couldn't control no more. So it probably stayed on and flew away until we couldn't fly anymore.
Yeah. We call that the return to China mode.
Yeah. So Bethany asked if I'm sharing the supply list. I'm gonna share the supply list, the link. So what I'm gonna do is I'm gonna give you the link for the actual original project, and you can look at all the things that are in there. And I'm gonna share all my STL files, which is the ones that I use, because mine is a little bit different from the original one. But yes, I'm sharing everything. I'm uploading everything to the T3 C3 Third Tuesdays trainings. I'll talk to Roxy or whoever's in charge of that, so they can make a list and then move it out of that folder so everyone can have the access. Stephanie, May 20th, it says there. Muted. Okay, May 20th is a Mavic drone workshop, I think. says.
I think I'm helping with that.
You are? Yes. So
Yeah, I'm looking forward to that. I just needed to write the date down. It went by too fast. Thanks.
Oh, Stephanie has it in the background of her.
yeah, for screen.
Okay.
She made it a background and walked away. So May 20th.
She's there.
And she's
there.
back.
Hey.
I'm sorry. It's like almost 3 here and I haven't gone to eat lunch. So I was trying to heat something up. Was there a question?
No, John just wanted to know. Sorry. Yeah, he wanted to know about the Mavic Mini drone workshop.
Oh, yeah. I don't know anything about that one. That one's so far down the road, unfortunately.
Okay.
I'm scheduling a meeting with Lindsay, or Lindy.
I think it's Lindy, yeah. Okay, then hopefully you learned a lot today and experienced that 3D printing can be taken to the next level to make something pretty cool. I'm gonna start seeing if we can take better pictures. And I appreciate the assistance to the workshop. Thank you, Stephanie, for support. John, appreciate it. I always say thank you because you're the first one to introduce me to the Upper Bound program and T3, and I've come this far. I like it. ET, again, appreciate it, man. It's good working with you. If there's any questions after this, my email is neldorial@t3alliance.org, I think it is. And you can email there, and I can send anything that you need for the telescope build or whatever other questions you have about 3D printing can be solved there too. You can go through Discord. We have the T3 Alliance server, and we have the 3D printing area. And you can also talk to ET. John has experience with 3D printing too. Any other questions?
I put Neil's email in the chat, everyone, in case you need it.
Great workshop, everyone. Thank you.
No, I appreciate it. Thank you for letting me show my work. It's pretty fun.
Oh, except I direct message it to John Monahan. Sorry about that.
He knows how to find me.
There you go.
Perfect. Hey, everyone. Thank you again for the opportunity. I appreciate it. See you soon. Hopefully you have fun.
Thanks everybody for showing up. We appreciate it.
Yeah, thank you.
Okay. Bye-bye.
Thanks,
Hey,
guys.
Good job.
Thanks, John.
Do you have to go? Do you have to go, Neil?
Oh, no, I can stay here.
I was going to show you the difference. So this is the sticky felt compared to the craft foam. You can see the difference in how much darker the felt is.
Yes.
But the sheets aren't, I mean, they're big enough to go inside the print. This says it's 9 by 12.
I know there's I think there's another way of doing that. Well, I don't know if that will work. I thought you were talking about where we use the glue and then we just drop in there, which will be permanent and it will stay there in the walls. But I don't know how effective that would be.
Yeah, and with the sun, it might heat up.
It will heat up, yeah.
Yeah, which is why I mean, like the one that I put in this one, which is the this is just press fit in. It just sticks itself in because I can just pull it out whenever I want. So
okay.
I just measured it and then it kind of just stayed in by itself.
That's pretty. I'll try that one.
John, wouldn't that if with the felt, wouldn't the particles from the felt eventually fall down onto the mirror?
Yes, but at a slower rate than dust.
Okay.
You're going to get probably more dust on the mirror than the felt's going to be. And it's just going to happen. I have a 10-inch diameter mirror telescope. I've never cleaned it. And I've had that for about 10 years. It's doing okay. Granted, I haven't used it for the last 2 years, but if it gets really bad, then yeah, I would probably clean it. But it's sort of like, have you ever used a DSLR or just a regular camera? You know how you get bad pixels, right?
Yeah.
You don't really notice it unless you're like pixel peeping and looking in at the picture, right? So there can be some that get really bad that need to be cleaned, but it might be a while.
Is it a weird way of cleaning, or is it just like a normal mirror? Just put something for cleaning.
You don't want to use regular water because there's going to be chemicals in it.
And minerals, I believe.
Yeah. So that's going to leave spots. So I think it's distilled water
Okay.
is what you use. So there won't be any deposits.
And a microfiber like this will work, like for the lenses and stuff.
I don't even know if you wipe it off.
You just water it down and just whatever.
I think so. I mean, there's some articles online about it. I also have a book called Telescope Hacks or Astronomy Hacks, and that goes through about that. But are you having any issues trying to look at objects at all, or just aligning it?
Yeah, I'm having issues because I never in my life used a telescope.
Mm-hmm.
I've seen a couple of them, but I never used them. So when I was looking for the moon, because it was finally out. It's been like cloudy for a couple of days, so I'm like finally, and I couldn't find it out, and I was like maybe I just leave it pointed up and eventually it'll appear, like it will just start capturing light, but no, and eventually I was just kind of frustrated, so I started moving the telescope like this, and then I see a flash, and when I saw that flash, I'm like, oh, okay,
Mm-hmm.
so I'm not where I'm supposed to be. So I moved a little bit back, and I started to play with it. And when I finally got it, I almost cried. So I pressed it down. And okay, the moon is right there, and then it was just blurry. It was just like a light. So I'm like, okay, I don't see nothing. I just see light. And I started using the focusing knob, being a little bit skeptical about it. Will it work? And then eventually, just bam, the moon was there, and I was just like, finally. So it's a matter of practicing how to find the moon where it is.
Mm-hmm.
And I read that I've read that if you have a compass and stuff like that, you might be able to. There might be able to say if you are looking the telescope at exactly 20 degrees after north, and if you put it at a 40-degree angle, you're gonna see the moons right there. So if that stuff is real, then all I need to do is adapt this to that, add something that I might be able to read that degree and all that stuff. I have a compass. I might be able to put something on top of the compass. But again, in the next design, not this one, because I don't want
to. I've used a inclinometer.
Okay.
So you get it at the hardware store. Mine has a magnet on it and it just sticks to the side, and all it does is it reads the angle of whatever it's at. So it's like I need to go up to 48 degrees, and you just boop and you stop it, right? And the other number is your azimuth. So it's just like north, Some software will tell you exactly those numbers. It'll say, south, southeast, but it's going to be like, 300 and whatever degrees.
Yeah, I have to move to that degrees. I know I have a compass, but might be able to get something for the Pi that has all that information already in it.
Yes.
And then if I'm able to do, I saw one person that built this, but they used the PVC pipe, so they have more time in their hands, and they 3D printed legs and rotors and gears. They were able to have something that moves from the computer, like move left a little bit, and a computer takes care of moving it. So if I'm able to do that, like that big of a design, and then updated it, that would be cool, because then from my computer, I can say, I'm here, move to this location, it will do it by itself. Now, that means way over there along the line. I got 4 jobs, and then I got my master's. So it's gonna take time for me to get there, but I will get there. But man, this experience has been like mind blowing. I have a camera. I'm like, I want to take a picture of the moon. Never been able to take a picture of the moon. And then here come I with a plastic made telescope, and I was able to take a picture of that moon that good. So yeah.
So some of the simplest ways of looking at objects is using a finder scope, right? It's like a mini telescope.
Okay.
I'm not all that together a big fan of them because they usually add weight to the front of the telescope, right? The other one that most people use is a red dot finder. So it's essentially like a little red LED that's reflected on glass, and it's mounted on the telescope. And when you point it, so okay, that dot's on the moon. You look through the telescope, you're on your object. It is the simplest thing in the world.
Okay.
Just because it's like, look up, look at the dot, you're there, right? If you have a green laser pointer,
You'll get
it's even better. You can attach it to the scope. You turn it on and just look where the dot is. You look where the laser is in the sky and turn it off and you're there. Now, obviously, you got to be very safe. No planes and stuff like that.
I know. I went through an experience in the military base where a friend of mine pointed at the plane.
Oh, gosh.
The plane deviated from where it's supposed to go. Got scared because usually over a military base, a laser means you're getting shot. So the plane deviated. It had passengers. He created a whole thing in Missouri, 2011. It was weird. So yeah, I know not to point at planes anymore.
Now you can get complicated and get one of these. Okay, so this actually is 3D printed because mine, it gets with the dew, it gets all wet. But I can't even get it off now. But it's a simple piece of glass, right? This is based on the Norden bomb site from World War II.
Okay.
So I'm going to see if I can do this. It's easy to do.
Oh, I can see a little circle.
Yeah. It's two concentric red circles. And they are certain degrees apart. So if you have a star chart and you have a transparency of those circles, you put it on the chart, and then you recognize, okay, this star needs to be in this part of the circle and then the inner part of the circle, and you just transfer to what you're looking through, and you're right on top of stuff. It can get complicated, but when I switched to using this, it's called a Telrad, my entire astronomy stuff changed because I was getting really frustrated in the early days. I can't find anything. I can't do anything. This is difficult. Got one of these, changed my life.
Perfect. I'm going to try the simplest one, which is the dot one that you had.
Yes, it's the same principle. It's the exact same thing.
Like a gun. Just look out. It's basically like a gun. You look through it, and that's it.
Some people have bought the Daisy air rifle ones because they're the exact same thing.
Well, just put it there. I'm pointing out that should be good. So I'll try that one. I'll look information and how I'm supposed to place it, and then have it and see if I can faster. I'm waiting for a full moon, and I'm going to see if I can take a picture of the full moon.
Oh, it's coming up.
Yeah. Here it was half moon, so that means a couple of days maybe, and it's always here. It's in the same place in the same area, and it gets huge and it gets yellow. So I want to see if I can take pictures. Question is, if there's clouds, will those clouds translate into the image, or will I only see parts of the moon that are not covered by clouds?
The moon will illuminate the clouds, so you're going to get a diffusion of the light, right? But you never know. Do you know what your let's see, I'm at 41. What's your latitude?
Longitude? I'm gonna tell you right now. Let me Google it. So I am in Lajas, PR, lat, and long. Let me see. So I am in 18.05 north,
Wow.
67 west.
Okay.
So yeah.
So the that sky charts thing that I put in the chat earlier, I don't know if you saw that. They print those every month. So it's like it's a free downloadable PDF. And there's northern hemisphere, southern hemisphere, and equator. So equator being 0, right? It might be close. But it'll give, like, on a given day, here's what you look if you rotate it to say south, and then you look south and you look up and you got it.
It's gonna tell you exactly what there is. Okay.
Yeah.
What kind of things can I see with this telescope? Only big objects?
Yes, we call that a rich field because you see a lot of things.
So I can see more than just the moon?
Yeah. So if you use the moon, the full moon as a basis in size, right? You can compare that to other objects or other fields of view. So you might get, say, 2 of the 3 stars in the belt of Orion, or in the scabbard where the Orion Nebula is, right? Bit of trivia, the Andromeda Galaxy is actually as big as the full moon, if you could see all of it. Now, I can see the Andromeda Galaxy with my naked eye, but I can't pull in that much light to get its actual size that you see in the sky. But with a telescope, you can pick it out. Now, Will everything look like the cool pictures from the Hubble? No, they won't. But you're going to get black and white, right?
It's pretty cool, yeah.
Yeah. And that's one of the things they teach you when you're looking through an eyepiece is if you don't see a faint object, sometimes you tap on the telescope just lightly, and the object, you'll see the field of view move, but your eye may see the clouds and things like that. It's really neat to do. But peripheral vision, right? You can actually, since you're coming at an angle, I've used averted vision to see objects that I couldn't see straight on.
Okay. Perfect. Appreciate it.
Mhm.
Oh, I'm so happy. I'm just waiting again. I'm waiting. So where I live, there's a light pole right there. So I know that affects a little bit. But where my mother-in-law lives, it's a little bit of a slope. It's dark. And when I say dark, you can see, you know, where you look up and you see like a line, and it looks like one of those, like a mini galaxy, just a lot of stars. So I wanna see if I can look at that and see what I see. So
You're going to see a lot of stars.
Yeah.
Because that's the Milky Way.
Yeah, exactly. That's basically what it is. So,
Mhm.
I'm gonna point to that, and maybe I'm not gonna, as you say, NASA quality pictures, but they're gonna be cool pictures. So
Do you have
yeah.
binoculars?
No,
Oh, okay.
I can get some. I can make some.
Hey, there you go. I don't know. I don't have my 3D printed binoculars with me right now.
Are they really good at it? Yeah, do they really work?
What they were just lenses that I put in a 3D printed enclosure.
Okay.
And
Everybody later. I gotta head out.
okay,
See ya. See you later, Corey.
Thanks,
See you,
ET.
John.
See you, ET. It's good to see you again, man.
Nice to see you too, man. See ya.
Yeah, actually, I gotta head out as well, guys. If you want,
oh,
you
it's
can
still
continue.
recording.
Yeah, I can stop that.
Yeah.
If you